Hey guys, I welcome you all to the live session on Spark Scala tutorial by Intellipaat. This session is conducted by an expert having more than 15 plus years of industry experience. But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. Now let's see the agenda of the day. Firstly, we will begin with Introduction to Apache Spark. Post that, we will be learning about Spark components and its architecture. After that, we will be explaining you in detail about Hadoop ecosystem. Then we'll move on to Introduction to Scala. In that, we will tell you what is Scala and why do we need it. Post that, we will be learning about dynamic type interface and block expressions. Then later on, we will be learning about Spark IDE and Scalar program. Post that, we will be learning about what are data frames in Spark. Then lastly, we have covered how to solve business problems using Spark. So guys, this is the agenda of the video. Now let's begin the session.
So the first thing that you need to understand is Spark is comparatively a newcomer in the big data world. When you say newcomer, see Hadoop came in 2005, and then if you look at the other projects like Hive or Pig or HBase, they all came somewhere in 2007 or 2008, etc. Spark was developed in 2010. So if you look at the history of Spark, Spark was created in 2010, 2009 or 2010, you can say, at University of Berkeley. So Spark was created as a research project. So a group of researchers at the University of Berkeley, they had a project called AMP Lab project. The project is still there, and they were just trying to create uh, a distributed processing engine, and thus they created Spark. And you also have to remember that in 2010, MapReduce was the popular big data processing engine, right? Because MapReduce came in 2005, and it was, very popular at that point in time. So when Spark was created, one of the goal was to create a big data execution engine, which is probably better than MapReduce. So if you really ask me where Spark fits in our Hadoop world, I would say that it actually sort of like replaces MapReduce. Even though Spark can do much more than that, but if somebody asks you like, okay, on Hadoop, where do we see Spark? Or when you compare Hadoop and Spark, where do you see it? My answer will be Spark is an execution engine, very similar to MapReduce, and probably better than MapReduce. So I will see Spark probably as a replacement for MapReduce, right? As a better execution engine. But like I said, that's not the complete story. Spark can do many more things, and we will get into that eventually. So in 2010, when Spark was created, it was kind of like a university project, and like I said, it was an execution engine, big data execution engine. Very soon, people found that Spark is much, much faster than MapReduce. So then what happened? The Spark project was contributed to Apache. It became an open source project. I think somewhere in 2012 or 13, it became part of Apache open source project. But again, it took couple of more years. People started using Spark in the industry by around 2015 or 16. This is my personal experience. As far as I know, it became popular somewhere around 2016, I would say, or 15, which means it is comparatively new, right? Because Hadoop came in 2005, and it was popular. But Spark is like in 2016. But from there onwards, it was a roller coaster ride. As of now, Spark is the most contributed and most widely used big data open source execution engine. So Spark holds many records actually. At one point in time, it has the highest ever number of committers in Apache open source projects. And today, even if you look at the industry, there is no big data project without Spark. So it's probably the most widely used big data project. Uh, Around 70 percentage of workloads uh, in around the globe, if you look at big data workloads, are handled only by Spark. So it's probably the most popular open source project right now when it comes to big data, right? Spark is specifically designed for big data. You cannot use it for other kind of case studies. In the sense, the real advantage of using Spark is if you have huge amount of data. Like if you want to process maybe 1 GB of data, probably Spark is not the right choice. You can have other execution engines as well, right? So that is a brief history of Spark, but then the real question that people usually ask is, why should I use Spark? And this is a question that probably people need answer to. Like, yeah, Spark is probably the most used project, but why should I do it? Why should I go for it? So obviously, it's a big data processing engine. So naturally, you can think about all the use cases where big data is involved. I'm quite sure that you have gone through many case studies and all in big data, and you were probably learning that using MapReduce. So wherever you find a big data problem and MapReduce as a solution, you can replace that with Spark. Spark will fit anywhere. But what are some of the other unique features of Spark? So if I go to the website of Spark, the first thing is, let's go to the official website of Spark, which is nothing but spark.apache.org. So you can make a note of this website because this website provides the up-to-date information, also a very nice documentation related to Spark. So the site is spark.apache.org. This is the website. And by the way, I almost forgot the original founders of Spark. Um, there are people like Mate Zaharia, Bill Chambers, the people who created Spark, right? These people, they went ahead and started a company called Databricks. So Databricks is the company which is created by the original founders of Spark. And Databricks basically sells Spark. So you can just go to Databricks and ask for Spark. Um, they have a proprietary platform. It's not open source. Okay. Also, they don't sell only Spark. It's kind of like a platform, but Spark is the what you say brain or heart or whatever of their platform. And Databricks is the leader in the industry when it comes to Spark, because these are the people who created Spark, right? So we will be using the Databricks platform for some of our hands-on. So Databricks provides a free platform for practicing Spark. Uh, you may not be able to do everything there, like all the hands-on, but some of the hands-on, we will switch to the Databricks platform and experience it there. Okay. Um, Now, when you go to the official website of Spark, you can see the definition. It says Apache Spark is a unified analytics engine for large scale data processing. Yeah, that's the definition. We'll come to the definition. And the advantages are already written in the website. First thing you see here is speed. So Spark can run your workloads 100 times faster. 100 times faster means what? In comparison with MapReduce. So this is not always true. I mean, these are what you say benchmark numbers. There were cases where they took a benchmark and Spark ran 100 times faster than MapReduce. That's true, right? But don't think like in the industry, every time you're running Spark, it's gonna be like 100 times faster than MapReduce. But yeah, it's fairly faster than MapReduce. I mean, you cannot compare them. On an average, my experience is if a MapReduce program takes, say, 1 hour, Spark will do it in 2 to 3 minutes, probably, maybe in seconds. So it's like nowhere near to Spark. So speed is definitely uh, one of the what you say advantages of using Spark, and how Spark programs are faster. So Spark does something called in-memory execution. So in-memory execution basically means, when you read the data, you keep all the data in memory. In memory means in the RAM. So as long as you're processing the data, the whole data is kept in the RAM or the main memory, and only the final result will be written back to the hard disk. When you go to MapReduce, this is different because in MapReduce, you have a mapper, then reducer. So after the mapper phase, whatever um, output is there, the intermediate output is going to be returned to the hard disk. So for a map reduce, it uses the intermediate output. It will write and then read. So it is kind of like slower. But when it comes to Spark, it is faster. So speed is definitely one of the advantages. Second thing is ease of use. Write applications quickly in Java, Scala, Python, R, and SQL. So um, if you talk about the programming languages supported by Spark, these are the ones: Java, Scala, Python, R. Now, among them, we are using Scala because Spark itself is written in Scala. It's one of the most widely used language when it comes to Spark. There are a lot of companies, for example, JP Morgan Chase, right? They use Spark with Java. The reason for that is more or less the developers or the workforce. So if you're working in a company and let's say you have a lot of Java developers, then it makes sense to, how do I say, go to Spark and then develop programs using Java, right? And especially if you are a person coming from machine learning, data science, deep learning, you're probably going to use Python or R. So for machine learning people, Python or R are their primary languages. So Spark supports that also. However, it does not really matter which language you are using. If you write a Spark program in Scala or Java or Python, it will run exactly the same. There is no difference, right? It just depends on what background you're coming from and which languages you are comfortable. Spark also supports SQL, so SQL, right? And SQL is probably most widely used with Spark now. So you can use Scala or Java and Python. However, more than them, Spark SQL is the library which is being used a lot. And we will get eventually there, and I will talk about what is Spark SQL and all these languages and all. So ease of use in the sense you just need to learn one language, maybe like Scala, and you can work with Spark, or maybe Scala or SQL, any of this, right? Now, the next thing that I want to talk about is something called runs everywhere. And this is, I think, a question that many people have. So people may be wondering, hey, where can I run Spark? I mean, where do I install Spark, right? Spark is practically platform independent. You can install it wherever you want. All you need is a cluster. So one popular option is you can run Spark on Hadoop. And this is a widely used option. So you can take Hadoop, install Spark on top of Hadoop, and then Spark can run on top of Hadoop. And one thing you need to understand is Spark doesn't come with storage. And many people have this confusion, right? There is no storage for Spark. Spark is like MapReduce. Does MapReduce have storage? No. MapReduce is just the processing engine, right? Very similar to that, Spark is just a processing engine. All Spark says is, okay, you store the data wherever you want, give me the data, I will process it. So when you say you are running Spark on Hadoop, um, HDFS will be the primary storage on Hadoop. Yarn will be your cluster manager. Spark will be the execution engine. You can also run Spark on top of something called Mesos. Mesos is another cluster manager like Yarn. So what I can do, I can take a bunch of machines and maybe I don't want to install Hadoop. Okay, so I can take a bunch of machines, install Mesos on top of them. So Mesos becomes like Yarn, your cluster manager. Then install Spark on top of that. In fact, the original Spark came on Mesos. You can also install on top of Kubernetes. This is, how do I say, container orchestration, microservices and all. So if you are aware of technologies like Dockers and containers and all, Spark very well works on top of that. Or in the cloud, so many of the cloud vendors like Amazon or Azure have their own implementation of Spark. You can go to them, they will set up Spark on a cluster and allow you to use it. Or there is a mode called standalone. Standalone mode basically means you install Spark uh, on a bunch of machines, and Spark will come with its own cluster manager. So what I'm trying to tell you here is, let me take a pen thing so I can talk about it. Yeah, so what I'm trying to tell you is Spark requires two things. One is storage and one is resource management. So if you're installing on top of Hadoop, what happens? You will get HDFS. This is the storage, correct? On top of that, you will get what? Yarn. Yarn is your cluster manager. On top of that, you install what? Spark. This is one option, and this is very common because many companies might already have a Hadoop cluster and they probably want to install Spark. So this is your storage, right? And this is your cluster manager, and this is Spark. The second option is you take a bunch of machines. So here I will just say machines and let them be your local storage. You bring up this cluster manager, which is called Mesos. and then you install Spark on top of that. Third option, again, you take a bunch of machines, and there is something called Spark standalone, and then you install Spark on top of this. So what I'm trying to tell you is all these are same. There is absolutely no difference in terms of execution, I'm saying. So Spark just says it needs to be installed somewhere. So you need to provide storage, a cluster manager for Spark to work. So one option will be I go to Hadoop. So their HDFS is my storage. Yarn is the cluster manager. Or I take a bunch of machines, create a cluster, and use something called Mesos. Mesos is another cluster manager. Or I take a bunch of machines and use something called Spark standalone. Spark standalone is where Spark will come with its own cluster manager. You are not using Mesos or Yarn or anything. Spark will have a Spark master, its own cluster manager, and gets installed in the cluster. So all three options are equally good. It's not like one is better, one is bad, or it's just your use case. That's all, right? So these are the common options you have. On top of this, you can install Spark on Spark in the cloud, as well as on top of Kubernetes and many other options, right? The other point I want to clarify is once you install Spark, so let's say you have installed Spark. One of the speciality of Spark is that it can read and write data from almost any platform. And this is, in fact, I think a great feature when you talk about the big data requirements and all. Because normally, when you look at the big data requirements, one challenge is okay, you might have data, but the data may be in different places. So Spark is capable of reading the data from, let's say, any RDBMS platform. So this can be Oracle, MySQL, Microsoft SQL, any of this. Or if your data is on top of any data warehouse. So this is like Teradata, Greenplum, Netiza, any of these data warehouses. If your data is there, Spark can read. Or you have your data on top of any NoSQL database. For example, your data might be on MongoDB, Cassandra, DynamoDB, Spark can read it. Or the data might be in any of the cloud stores, Amazon, Microsoft, Google, uh, any of these cloud, right? Or it can be even in other systems. For example, Spark can read from SAP. There is an SAP connector. Spark can read from mainframe. There is a connector. Spark can read from, if I remember correct, it can also read from Salesforce. There is a connector. Spark can also connect with almost all the BI tools. So, for example, Tableau, Informatica, Spotfire. So you see, this tool is not what we are thinking, right? Look at the connectivity options. You are saying that you can connect to almost any platform. I have listed almost everything that I know. RDBMS, data warehouse, NoSQL, cloud, SAP, business intelligence, ETL. Almost any tool you bring in, Spark will be able to read and write the data. Accordingly, Spark is being used as an ETL tool now. So there are many organizations who use Spark as an ETL tool, and an excellent one, because the challenges will be even in the big data world, you have your data lying in many different platforms. You might want to read and aggregate them, clean them, and write it into some other platform. For example, I might have data in MongoDB. I might also have data in Salesforce. I don't know. So I want to read this, combine them, write it back to, let's say, Oracle. Spark can be used. So one of the use cases of Spark is uh, connecting to a variety of data sources and bringing the data and then transforming the data. And I will show you an example of how Spark can be used as an ETL tool in our course, right? So this is another great feature of Spark. So what did we discuss? Coming back to the discussion. So I was telling you why somebody should use Spark. Why somebody should use Spark? The speed. So definitely it is faster, and the ease of use, like you can use one language and then do anything, runs everywhere. So you can bring it up on any platform, doesn't matter. Also, it allows you to read and write from any type of data source. If this is not enough, right? See, the classic problem with Hadoop is, so we always try to compare Hadoop and Spark, but the classic problem with Hadoop is if I go to Google and search for Hadoop ecosystem tools, let's say go to here. So have a look at this picture. So this picture talks about Hadoop ecosystem, or this picture talks about what is Hadoop and uh, what are the tools you can install on top of Hadoop. So as you can see, Hadoop has HDFS, then Yarn and MapReduce. Fine. So this is, oops. So this is basically the core of Hadoop. Like you have HDFS, then you have MapReduce. Now the point is when Hadoop initially came, okay, it was supposed to be a batch processing platform. Even if you look at the definition of Hadoop, you will see that Hadoop is a batch processing engine. So all Hadoop does is, okay, it takes a bunch of data and do batch processing. Now, again, for this, what happened? A lot of tools were created. So if you look at Pig, Pig was created so that MapReduce programs can be written easily. Okay, so there is a engine called Pig, right? Then some folks said, okay, Hadoop is great, but we want to do SQL on top of Hadoop. Okay, and that is how this tool called Hive was created. So Hive is basically what? SQL on top of Hadoop. Some other guy said, okay, you know what, everything is fine, but we want to use machine learning on Hadoop. So for machine learning, Mahout was invented. Then some other folks said, okay, we want tools to ingest the data. Then Scoop and Flume were invented. So the problem is this Hadoop ecosystem is ever growing. So for each type of analysis, you have one tool. For SQL, people use, let's say, Hive. For machine learning, they use Mahout. For batch processing, they use Pig. So I have to learn like, I don't know, 5, 6 different tools when I want to work with Hadoop. The advantage of Spark is when you come to Spark, this is the Spark libraries we have. You just download Spark and install it. And whatever Hadoop and all these 6 different tools were able to do, Spark alone can do it for you. So Spark comes with built-in libraries. For example, if you are interested in just batch processing, okay, you are a developer, you just want to read some big data and do some batch processing, you use something called Spark Core. So this is basically what you call, this part is what you call Spark Core, okay? Spark Core is basically the execution engine. And here you get this abstraction called RDD. I was talking about RDD, right? So one of the ways in which you can program in Spark is using this Spark Core and then RDDs. So what you're doing here is you're going to Spark and you're saying that, okay, I just want to do batch processing. That's all. and I'm a developer. So Spark will allow you to directly interact with your core library.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. Data frame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
On the other hand, you say that, okay, I'm a SQL developer, then you go to Spark SQL. So Spark SQL is where you are using your SQL library. So you can create tables, write SQL queries, do join operations, just like whatever you are familiar with SQL. If you want to do real-time data analysis, you go to Spark Streaming. So Spark Streaming is where you have real-time data analysis. And this is something I guess people might not have seen. So normally in the Hadoop world also, all the tools are created to do batch processing. There is no real-time processing. Spark provides you with a library called Spark Streaming, which can do real-time analysis. And I will explain what it is later. Now, if you want to do machine learning, there is a library called, uh, you know, MLlib. So MLlib is the library which allows you to do machine learning. There is even a library to do graph processing. So the real deal with Spark is it is not only faster, it is not only easy to work with, it is not only something which you can install everywhere and read from everywhere, it comes with a bunch of libraries to address any kind of workload. So in the modern day big data projects, our problem is really this, and Spark solves it. The problem in modern day projects is that I'll give you an example from my experience. Imagine you are designing a system which is going to catch credit card fraud. So credit card fraud is a very common thing, right? So, what happens? A lot of people steal the credit card, they will hack and, they do fraud, identity theft. So maybe you have a credit card, somebody will steal the number, the CVV code, then they start using it. So credit card fraud is very common. And what happens is, if I want to design a system which can catch, let's say, credit card fraud, what are the challenges? So my first challenge is this system should be real time. Real time in the sense, millions of people might be swiping their credit cards, right, during peak hours, and you want to catch it and then probably make a decision, right? So if I am getting all the credit card transactions today, if I analyze it next month, it is going to be useless because uh, this is fraud and you have to do it in real time. So I need a system which can process, say, 1 million transactions in a second and make a decision. So you can use Spark, and there is Spark streaming. Then in the credit card fraud system, I also want to implement machine learning because usually when there is some sort of a prediction, like whether it is fraud or not, machine learning is heavily involved. So again, you can use MLlib in Spark. And in the credit card, what you say, fraud detection system, I probably want to use SQL, so I can use Spark SQL. So you see, using the same Spark, you are able to implement three-way approach actually. This is not possible in Hadoop. When you go to Hadoop, the problem is for SQL, you have to install Hive. For machine learning, you need to install Mahout. For real-time processing, you need to install something called Storm. And integrating all these tools together is a challenge. But in the world of Spark, like I said, um, it comes with all these built-in libraries, so you will be able to perform uh, all these kind of analysis using a single tool. And that is the real advantage of using Spark. Um, I'll get back to your questions in a moment. Also, I think probably I spoke about it, but if you look at the versions in Spark, right, Spark has three major versions. There is something called Spark 1 or the 1 dot release, we call it. Nobody uses 1 dot release, it's pretty old. Then you have something called Spark 2 dot release. 2 dot release is what people use in the industry uh, as of now. There is also Spark 3 dot. Some of the customers started using it, but it is comparatively new. We will be using Spark version 2.3.1 in our course. So now I can quickly, refresh the slides to talk about these things, right? This is exactly the same thing that I was talking about. So if I go here, yeah, this is again the same Spark architecture we were talking about. As you can see, on top, you can see the languages, Scala, Java, Python, R. Then you can see the libraries, Spark SQL, Spark Streaming, MLlib, and graphics, right? At the bottom, you have Spark Core. And like I said, it can read from all these platforms. So you have many platforms actually listed here. You have like Cassandra, HBase, MySQL. And I almost forgot one more thing. Okay, so I almost forgot one more thing, which is Spark is also capable of reading any file format. And I will show you an example for this. Uh, File formats are very important. So you might be aware of CSV, JSON, XML. So Spark can read all of this. On top of this, there are some big data file formats. We have ORC, Parquet, Avro. Spark will be capable of reading any of these file formats, right? And convert them from one format to another one as well. So then what we spoke about. So this is again the categories of Spark components. Again, same thing I was talking about. The programming languages you can see, the libraries you can see, but end of the day, the execution will be handled by Spark core engine. Then cluster manager can be Yarn, Mesos, or Spark scheduler or Spark standalone. Storage can be HDFS, standalone machine, cloud or RDBMS, even NoSQL. Um, so one more thing you need to understand is the data need not be always with Spark. For example, you might have installed Spark on top of Hadoop, but that does not mean like you have to keep all the data in Hadoop. Yeah, it can read from Hadoop, but the data may be, some of the data may be in Cassandra, some of the data may be in cloud. Still, Spark can read and process it. So like I said, it's a processing engine rather than something like Hadoop. Okay. Yeah. So what we have to understand now is something called Spark architecture. So we will build on the Spark architecture. I mean, we will understand the basics and then, you know, we will build on that knowledge, what it is. Uh, See, usually what happens is I might have to use my pen. So usually what happens is when you create a Spark program and then submit the program, you definitely need resources to run the program. And I think this is something everybody agree, right? So you may be processing a 10 GB file, or maybe you're processing 100 GB file, or you may be processing data from different sources at the same time. So whatever you do, one thing is sure, you need resources to run the program. So one way to get this is from the yarn. Not one way, the only way. So who will give you resources? Resources will be given to you by the cluster manager. Let's say yarn. So we are assuming that Spark is running on top of Hadoop. So if that is the case, the cluster manager is yarn, and yarn is supposed to give you all the resources to run the job, right? And what happens in case of Spark, the resources are given to you in the form of something called executor. That is what you see in the picture. So there is something called executor. What is an executor? Uh, in Spark's terminology, executor is a combination of CPU and RAM. That's it. It is like a container given to you so that you can run the program. An executor is a combination of CPU and then RAM. So you can go to Yarn and ask for as many executors as you want. Also, you can decide what is going to be the configuration of the executor, like how much RAM, how much CPU cores, all you need. And this has to happen depending on the data that you are handling, right? So depending on the data and the complexity of the program, that you're written, you can probably ask uh, for this. So typically the executors are allocated uh, um, based on the decision of Yarn. Now, this is actually a very crucial thing, but in my experience, you will not be the only person who will make this decision, right? Because let's say you created a program and you want to run the program in a cluster. Now, you may be reporting to somebody, or maybe someone else will also be responsible for running this program, right? So you are probably not the only one who thinks, okay, I can run the program. uh, Now executors can be launched on each of the machine. So if you have 100 data nodes or 50 data nodes, on each of them, executor can be launched. And there is a calculation that typically you use. To show that calculation, we need a cluster. So I'm just going to use a cluster that I know. Don't worry about this. So there is something called CloudX Lab. So I'm just going to log on to this lab so we can see what the resource policies are in this cluster. Let's try to log in. So the executors are allocated by yarn. So you need to go to yarn. Okay. You go to yarn and you will be able to see some of these options here. I don't know where to find it. Let me just check in this cluster. So if I go to yarn, non-manager, if I go to configuration, yes. So, see, first thing you need to understand is if you go to what you say yarn, you can find these requirements. There is something called memory node. Memory allocated for all yarn containers on a node. So there will be restrictions. Okay. So in this cluster, what you see is memory allocated for all yarn containers on a node is 9 GB. So you can see this value. This value is 9 GB. So maximum 9 GB is in this cluster. In the real world, it might be bigger. Okay. In this cluster, maximum RAM that can be allocated for an executor is 9 GB. Minimum is, okay, so that is for all yarn containers on a node, right? And then there is a minimum container size and maximum container size. So you can set it individually. So minimum is 128, maximum is actually 5 GB, right? So all containers put together, it should not cross 9 GB total. For an individual container,
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
right, minimum 128, maximum 5 GB is the size. So let's take these things in account so I can write it. So on a machine, maximum memory of all executors put together in this cluster I'm talking about, okay, executors is 9 GB. Minimum memory for one executor is 128 MB as per this cluster. Maximum memory for one executor, that is 5 GB as per this cluster. Okay, you also have settings for CPU. So if you scroll down, this is CPU. So you can see minimum container size is 1, maximum container size is 8. So for CPU, what they say is minimum CPU for one executor is 1. Maximum CPU for one executor equal to 8. Okay, so these are the settings. This is set by your administrator. That is why I'm showing this page. See, this is the yarn page of this cluster. So you can see the total RAM for all the executors together is 9 GB. Minimum RAM is 128, maximum is 5 GB. And minimum CPU core you can ask is 1 core, maximum is 8 core. So you need to first understand this, then only you can ask for resources. Now this may change for different clusters. And these are very small numbers because this is a training cluster. In the real world, this might be in gigabytes and very big numbers, but you need to understand this. And now if you come to this picture, what you do is typically when you are creating a Spark program, you create a Spark program, and within the program, you will be able to set all these numbers. I will show you how that can be done. But typically when you write a Spark program, within the Spark program, you will be able to ask resources to run the program. And when you launch a Spark program, what is going to happen is, take my pen, there is something called driver program. You can see this blue box. The driver program will start on one of the machines. So I'm just assuming this is my data node 1. So remember we discussed about driver program even in Scala. What is the driver program? The driver program contains settings to run the program. So this can be, for example, the resources you are asking, the compression that you are using. All this is part of the driver program. So typically what happens is the driver program will initialize on one of the machine, and it is going to create an object called Spark context. So Spark context is basically an object. Okay, it is an object, and this will be initialized by the driver program. Now, why do you need this object? Because once this object is initialized, you can see using this object, the driver program will talk to your cluster manager. The cluster manager in this case is, let's say, Yarn. So driver program starts first. It will initialize the Spark context object. Using that object, it will connect your cluster manager Yarn, and then the driver program will negotiate resources from yarn. So in this simple example, you can see there are two executors. So the driver program is going to yarn, will go to yarn and say that, hey, you know what? I need two executors. And you will also say that, let's say each executor, let it have 8 GB of RAM and 8 CPU. As an example, I'm giving. So each executor, you are assuming you have like 8 GB of RAM and 8 CPU. So the driver program will go to Yarn and say that, hey, Yarn, in this program, the developer has asked for two executors, each with 8 GB RAM, 8 CPU. So Yarn, what it is going to do, it will launch these executors. Now, you really don't have any control here. If there are no resources, right? So suppose sometimes what happens, your cluster may not have enough RAM. Then what will happen? Yarn will not launch any resource for you. Your program will wait in the queue. Nothing will happen. But assume you are in the ideal environment where there are resources in the cluster. What Yarn will do? Yarn is going to launch two executors. Now, again, there is no control as to where these executors will be launched. Yarn can even launch both the executors on one machine. Quite possible. That depends on the discretion of Yarn. But let's assume that in this ideal example, Yarn launches one executor on each of the data nodes. So this is my data node 2, okay? And this is my data node 3. These are three data nodes in the cluster. So Yarn launches one executor on data node 2, one executor on data node 3, and each executor has 8 GB RAM, 8 CPU cores and all. And now your driver program will push the business logic in the form of something called task. So if you're wondering what is this task, when we write the program, I will show you. But if you write a Spark program, it will be broken down into smaller pieces of unit called task, which can be executed. So the driver program, now since it has got the resources, it starts pushing these tasks to the executors and they execute it parallelly. Once the program execution is over, the final result will be sent back to the driver program. So driver program is the one which will be getting the final result or output or whatever you call. So driver program gets the final output, right? And then the executors will be deleted. Executors are only required at runtime. You don't need them like all the time. They are only required at runtime. Once your processing job is over, executors are also deleted. Now the question will be, how do I know how many executors I need? Well, there is no hard and fast answer to this. Okay, so next question will be, okay, I got the idea. You're saying that to analyze the data, you will ask for executors. But how do you know that you need two executors? Or better, how do you know that each executor need 8 GB RAM? Like, what is the logic that you're using here? Well, the logic is something that probably has to come with experience. To give you an idea, if you have a 50 GB file, let's say you have a 50 GB file to process, I can ask for even a single executor with 50 GB RAM, but that is probably not a good idea. So as an example, what I'm going to do, I will launch 5 executors. This is just an example. Okay. 1, 2, 3, 4, and 5. So this is my executor 1, executor 2, executor 3, 4, and 5. So I'm going to launch 5 executors in this example. Each executor gets, let's say, 10 GB RAM. So each are going to get 10 GB RAM. Also, each executor will be getting 10 CPU cores, assume. So I'm just going to say 10 CPU core. This executor, 10 CPU core. Again here 10 CPU, 10 CPU, 10 CPU. So I have requested for 5 executors, each with 10 GB RAM and 10 CPU core. Now the problem is how this 50 GB file will be loaded in 5 separate machines or 5 executors. So Spark uses a concept called partitioning. Spark has a concept called partitioning. Partitioning is nothing but dividing your data. That's all. So when you are reading this file, 50 GB file, you can ask how many partitions you need on this file. So I'm going to say that, okay, I want to divide this file, this 50 GB file, into 50 partitions. So when you say 50 partitions, each partition will be like 1 GB. Okay. And then what is going to happen? Partition 1, then partition 2, partition 3, up to partition 10 will be loaded here. Again, partition 11, partition 12, partition 13, up to partition 20 will be loaded here. Partition 41, partition 42, all the way till partition 50 will be loaded here. That is how the processing will happen. So I think I spoke about too many things at one time, and maybe people are kind of like confused probably. So I will reiterate what I'm trying to explain. So first thing is, how do you decide the number of executors? Now there is no hard and fast number, like I said. In this example, I'm calling for 5 executors to fit 50 GB data. So rough figure will be, if you have 5 executors with 10 GB RAM, you fit 50 GB data. You can also ask for 10 executors with 5 GB RAM, right? That also works. But normally the rule is the number of executors should not be too less or too more, what you call, right? See, if the number of executors are very less, like you're calling for 1 executor, then only 1 machine will be participating in the processing, and it will be very difficult to process the data. If the number of executors are more, for example, for this 50 GB file, I can call for 50 executors. Absolutely possible. But if I call 50 executors, the problem is there will be a lot of data shuffle operation. Sometimes, say you are using Spark and you do a join operation, the data might have to travel from one executor to another executor. So if you have too many executors, that will be a problem. So I came up with a number 5. Okay, that is my golden number probably. Each executor get 10 GB RAM. So 50 GB can be accommodated there. Now the most important point here is processor. Processor. Why processor is important? First of all, processing has to happen, right? Data needs to be processed. So you need CPU. The second reason is CPUs are not easily available, meaning I can have a server with 200 GB RAM. I cannot have a server with 200 CPU. Check it out. I don't think it is possible. CPUs are limited. Okay, so when you plan your processing, you should consider CPU. It's not possible to process your data if you have only RAM. RAM cannot do processing. So that is why in this example, for each executor, I have allocated like 10 CPUs, 10 CPU core. So now the rule is you have 10 CPU core, and ideally each processor core can process some data. That is where partitioning comes into picture. So this 50 GB file, when you're loading in these executors, you can partition them.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and Dataframe? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
And I will show you how to do this practically, but you can basically run a command and the file will be split or partitioned. So I decide 50 partitions so that each CPU core in an executor get one partition to process. That is ideally how you should design. So when you have a processor core or a CPU core, it has to work with one partition. And there is no golden rule as to what is the size of a partition, but 1 GB is something typically we can consider. Even it can process 2 GB or 4 GB, but in this simple example, this is what we do. Now, you don't have to break your head some ground rules, and also you don't decide this on your own. You cannot go to your company and say that, okay, I learned Spark, I'm the boss, I'm deciding partition. You will be fired the next thing. So you need to take permission from people to do all this, because this all affect the cluster, right? So yeah, your theory might be correct, but you need to, discuss this with other people, maybe your administrator. You ask your administrator, hey, I have 50 GB data. I'm going to launch 5 executors. Will it work? He will say, no, it's not going to work. Increase it to 7. Some reason, right? So you need to adjust all this. But end of the day, the total RAM uh, among all the executors should fit your data, and the CPU cores should process each partition. That's kind of like the rule. Okay, I'm bored with theory. Let's go to hands-on. Since we spoke so much, I thought I will do something. I will show you what. Okay, let's open the Intellipaat VM. I'm just going to open this Intellipaat VM. But I want to show you a couple of things before we get into the actual hands-on kind of thing. So I'm starting the Intellipaat VM, and I am connecting with the VM. Intellipaat VM. And in order to work with Spark, there are many ways. If you want to write a Spark program, you can always use an IDE like Eclipse we have seen. So you will be able to develop your Spark program using an IDE. I will show you that. But more than that, Spark also provides us with an interactive shell. So if you want to work with Spark using Scala, all you need to do is just type this command spark-shell and hit enter. So this command spark-shell, this is going to launch something called Spark Interactive Shell using Scala as the language. So once we get the Spark shell, we will be able to type the code and execute it and see and all. So as you can see, when I type Spark shell, you can see the Spark version is, okay, it's 230, not 231. That's okay. So you see Spark has started. Version is 230. And you can see the Scala interpreter. So basically, Spark has started, and I'm using this Scala language to write programs on top of Spark. So One thing I wanted to show you today was that you can just type spark hyphen shell, and then you get an interactive shell for Spark. Um, and also you see something here, it will be written Spark context web UI available at this location. So whenever you start the Spark shell, Spark also gives you a web UI. It will be available in 4040 port number. I can just copy this, go to my browser, paste it, and there you go. So this is the Spark UI. And as of now, you don't see anything in the Spark UI because, typically when you run any program or any logic, then only Spark UI will display something. As of now, the UI is completely empty. We are not going to run a program, right? And I can exit from here. Now, if you are a Python developer, there is something called PySpark. So PySpark is where you will be working with Spark using Python. So in order to get the PySpark shell, you can just type PySpark. So I'm going to just type PySpark, hit enter. And what happens here is again the Spark shell will be started. But now you can see again Spark came, but you don't have Scala here. You have Python. So now are you able to understand the connection between Spark and the languages? Spark is the execution framework, and you can program in Spark using any language. So this is your PySpark. So I just typed PySpark and this started. And now I will be able to type Python commands here. They will be executed by Spark if I want to do that. Well, I think we will not be using PySpark. So I will exit here. Let me start this uh, Scala shell once again because I want to show you one more thing. So we will be working with this command called spark-shell because this will bring the Spark interactive shell in Scala. And this is where we will be spending most of our times. And I want to show you one more thing. So when I start Spark, it says that the web UI is available in 4040. You can see that the version is 2.3.0. It also says Spark context available as SC. What is this Spark context? Go back to the diagram. So Spark context is this object using that your driver program is communicating with the cluster manager. So normally when you start this Spark shell, the Spark context will be automatically created for you. So you can see Spark context available as SC. SC is the name of the Spark context object. Also, you see something interesting. It says master equal to local. What is this? There is something called local mode in Spark. What is local mode? In local mode, Spark will run only on one machine inside a single executor. So driver, executor, everything is going to be inside a single machine, single JVM. That is local mode. Why? This is good for learning, development, testing, and all. Local mode is great if you want to experiment with Spark. See, if you want to learn Spark, you don't need 100 node cluster, right? Spark will behave exactly whether you are running it on one machine or 100 machines. So by default, when you start Spark, you see it is starting in what? This local mode. Now you can do everything in Spark using local mode, but the difference here is, like I said, it is using our Intellipaat VM. Intellipaat VM is one machine. So you are not actually getting a cluster. But I wanted to show you a cluster as well. What I'm going to do, I'm going to use Google Cloud. Well, any cloud platform will do. But if you go to Google Cloud, okay, I have an account with Google Cloud. You don't have to do this, don't worry. If you go to Google Cloud, they allow you to quickly launch a Spark cluster. It's very nice. I'll show you. So you can go to Google Cloud. There is a service called Dataproc here. I go to this service called Dataproc, and I can ask Google Cloud to give me a Spark cluster, Hadoop and Spark cluster. How? So it says here, Google Cloud Dataproc lets you provision Apache Hadoop clusters and connect to underlying data stores. It will come with Hadoop and Spark. So I can just say create a cluster. Okay. And I can give a name for my cluster, not required right now. And cluster type is like one master and n worker, meaning you will have one master and n number of data nodes, what you call. Scroll down, enable component gateway. I can go to configure nodes, and you can select whatever type of machines you want in the cluster. So I'm going to use this N1 machine. You get like 4 CPU, 15 GB memory. Okay. And hard disk space, I don't need like 500. I can ask for some 30, right? Then worker node also, I will say 2 worker nodes, just 30 GB hard disk space, say create. See how easy it is. So now Google Cloud is creating this cluster and this is chargeable. Don't try if you're not aware of cloud computing. This is chargeable, highly chargeable. Okay. I think for running this for an hour, they charge $10 or something, even more than that sometimes. So this is highly chargeable, but very easy to demonstrate something like this. So now what Google Cloud is doing, they're creating a cluster for us, right? So you can see the cluster is provisioning, right? And it is happening. Meanwhile, I need to check something. Let's look at Stack Overflow. Okay, anyway, go here. The cluster is running anyway. So we have the cluster running, and why I wanted this cluster is I can just go to the cluster, and in here, what I want to show you is, where is the VM instances? Let me connect with the cluster. So how do you launch the Spark shell in the cluster mode? That's basically what I wanted to show you. So in the Intellipaat VM, when I say, okay, start the Spark shell, you're getting something called local mode, right? So here, since we have a cluster, what I can do is I can say Spark shell, then I can say hyphen hyphen help. So if I take help from the Spark shell, you see a lot of interesting things here. For example, the master URL. So the default master is client, meaning by default, Spark Shell is going to start in the client mode. Okay. Sorry, local mode. Sorry. So the default is local mode for master, but you can ask for Mesos as your master, Yarn as your master, Kubernetes as your master, Spark itself as your master. So we will say start the Spark shell and we will say master is Yarn because we have a cluster. What else can you do? Look at this. Driver memory. So how much RAM or the main memory you should give for the driver? So that is the driver memory. And look at this. Executor memory. So how much RAM you can ask for the executor? Then here is the driver cores. The CPU cores you can ask for the driver. And here is executor cores. So let's try to launch Spark Shell like this. I'm going to say Spark Shell. The master is yarn. And I'm going to say number of executors, 5. I need 5 executors. Then I'm going to say executor memory 2 GB. Then I'm going to say executor cores 2 2. Executor cores 2. Then I'm going to say hyphen hyphen conf. Now I need to put this. Spark dynamic. Yeah. Hey, this is enabling. I will try this hyphen hyphen conf I need to give. I think this will work. Let me just check. Give me a minute. Equal to force. I will tell you what I'm doing. So what we are doing here, we are launching a Spark shell, and we are saying that, okay, hey, go to yarn. Okay, just go to yarn and ask for 5 executors, each having 2 GB memory and two CPU cores. So I will tell you what is this dynamic resource allocation, but you can see this started. And now if I go to Spark UI, I will be able to find it. So how do I find this in the Spark UI? I can go to web interfaces. I can go to resource manager, go here. And this is the Spark shell. I open this. I go to this UI. Okay, so you got the Spark UI in the Google Cloud. And here, quite interestingly, expand this event timeline. Can you see there is something called event timeline? And if I expand, it says executor driver added. So this is your driver, which started first. Then you have executor 1, 2, 3, 4, 5. So you can clearly see that we asked for 5 executors and Spark launched it. So first the driver will launch, it will negotiate with yarn, get 1, 2, 3, 4, 5. So you're getting 5 executors here. You can also go to this executors page here, and it'll show you all the executors. If I scroll down, see, this is my driver. This first thing I'm highlighting is the driver. And below this, you can see 1, 2, 3, 4, 5 executors are there. So these are all my executors launched 1, 2, 3, 4, 5. Okay. So this is something I wanted to show you. Like practically you can see these executors and all, something I just wanted to show you. So you can clearly see here, 1 driver added, then 5 executors. So I will probably delete this cluster because otherwise this is chargeable. So I'm just going to delete this Google Cloud cluster. It's actually chargeable. The Scala programming language. Scala, what is Scala? There is a car by the name Scala, by the way, but I have never heard a Scala as a programming language. What is it? Who created this? When did it come? You know, you tell me Python, you tell me C# or Java. I know this. What is Scala? I never even heard about it, and you are going to talk about it. Well, honestly speaking, Scala is a very popular programming language, but you know it is really popular in the big data landscape. Okay, so if you're even in the traditional world, there are projects which use Scala, but in the big data landscape, Scala is extremely popular. Now, the first question that probably I need to answer is why somebody created a language called Scala? Because there are too many programming languages in the world. Then why did you come up with another programming language. So Scala was created somewhere around, I think, 2004 or 2005, roughly around that. And the real reason for Scala was, I would say, in a way, Java. So if you look at the industry, probably around 2001, 2002, and all, the industry largely had two type of programming languages. Okay, so one type of programming languages were languages like Java. So if you look at Java, Java is in fact one of the most popular programming language, right? Um, and Java is platform independent. Most of you might be aware of that. You can install Java wherever you want, and Java programs are highly optimized. But the problem with Java, now I don't call it as a problem, is that it is very difficult to learn. Now, if you are a newcomer in the programming world and then you try to learn Java, then it's gonna be hard. It's not that easy to learn Java, right? So on the other hand, you had other type of languages, for example, like Python. So the advantage of Python is it is more or less like a scripting language. It's very easy to learn. Anybody can learn practically. So Python code is more or less written like you write English. So the way you can learn Python is very easy. On the other hand, Python lacks some of these optimizations which uh, you know Java provides. So you have like two type of languages. One is probably languages like Java, which have all the benefits of platform independence, optimizations, but they are kind of like a little bit hard to learn. On the other hand, you have languages like Python, which are like super easy to learn. But Python lack a lot of optimizations that languages like Java provides. So Scala came as a language which takes the best of both worlds. So to put it in the technical terms, I would normally say that Scala was the first programming language which supported both object oriented and functional programming styles. So this is the real reason why people started using Scala. So first question that people usually ask is, okay, why should I learn Scala? You are going to teach Spark, but then why should I learn Scala here? So the first reason is the Spark framework is written in Scala programming language. So if you look at Spark, the Spark execution engine itself is created using the Scala programming language. And you know that, or at least you will come to know that, Spark is one of the most popular and powerful big data processing engine. And that engine itself is coded in Scala. So this makes Scala one of the preferred languages when people start learning Spark. Point number one. Point number two, Spark is written in Scala. So our execution engine, Spark itself, is written in the programming language Scala. And Scala is a very powerful programming language. And the second reason that you can uh, probably appreciate is Scala is the first programming language which started supporting both object oriented and functional programming styles. So this is probably the reason why people started using Scala or preferring Scala. Scala was the first programming language which started supporting something called object-oriented and functional programming styles. So if you look at the world, and Scala came somewhere in 2002 or let's say 2003, if you look at the world somewhere around 2002, one set of languages were there, for example, like Java, right? So Java is a language which is, purely an object-oriented programming language. So maybe some of you are not coming from the programming background, but I'm sure that you have heard about Java at least, right? So there are languages like Java, then you have C++, so these languages support something called object-oriented programming style. So in object-oriented programming style, the basic idea is you have something called classes, then people will be creating something called objects out of them, and then you will be representing your data structures using them, so on and so forth. We don't have to go deeper into object-oriented programming, but just understand that probably way back in 2000, one set of languages were there which were very popular in the object oriented style, right? Or it is called oops sometimes. And these languages were like Java, then Schema, C++, etc. Now if you look at a language like Java, Java is in fact a very powerful language, and it is platform independent and probably one of the most used language in the world. But one of the challenge was it was really hard to learn Java. Now, if you have ever learned Java, you will know this, right? Java is not probably a language which is very easy to learn, right? It is a little bit hard to, how do I say, learn the basics and write your code in Java. So the problem with traditional object-oriented style languages were that, they were not very easy to learn and master. So when Scala came, Scala was a language which had the support for object-oriented and something called functional programming style. Now we will see what is this functional programming as we go ahead, but just try to understand that functional programming is a way of programming where it is really easy to write your code, and you will be using a lot of features related to functions. So there is a concept called functions in every programming language. In functional programming, we use a lot of different styles of functions, and it is very easy to write your code as compared with object-oriented programming. So when Scala eventually came, Scala started supporting object-oriented and functional programming style, and it started becoming a favorite for many people. So this was in 2002, and after the introduction of Scala, a lot of other languages also started supporting functional programming. For example, if you look at Python, Python has functional programming support. If you look at Java itself, the modern versions of Java, that also supports functional programming style. So functional programming is a way of programming basically where you give a lot of preference to functions and you try to reduce the number of lines of code. It is very easy to write a code in the functional style. And when we go to writing Spark programs, we will be following the functional style, not the object-oriented style. Even though Scala supports object-oriented style, we will not be following that when we go to writing our Spark programs. So the speciality of Scala is it was the first language which started supporting object-oriented and functional programming. And eventually, when we go to big data platforms like Spark, right, Scala is used in the functional approach. And when Scala was created for the first time, it was modeled around Java. Java was very popular at that point in time. Even Java is popular now. So when Scala was first created, a lot of concepts and libraries were taken from Java. And Scala is a completely compiled programming language, meaning if you write a Scala program and if you say execute the program, the code is going to get compiled, and this compiled code can be executed by something called a JVM. So I will write it here. The Scala program, once compiled, can be executed on a JVM. What is a JVM? Java Virtual Machine. You know why Java is so popular? Java is very popular because it is platform independent. You can run Java programs practically anywhere. It will run on Windows or MacBook or Linux or you name it, Java will run. How? The answer here is something called JVM. JVM or Java Virtual Machine is a platform where Java can run. And you can install and set up JVM.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. Data frame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Almost on any platform. The same JVM can be used by a Scala program as well. This means Scala programs are platform independent. So when you write a Java Scala program and compile it, this program can be executed on any platform as long as that platform has a JVM installed. So when it comes to the execution of the program, Java and Scala are very similar. In fact, Scala produces the same bytecode that you know that comes from a Java program. And I believe when you want to learn a programming language, probably than theory, a little bit of hands-on might be more useful. So at Intellipaat, we have this VM, right? Intellipaat VM. And we will be using the VM for most of our hands-on exercises. So what I'm going to do, I'm just going to start my Intellipaat VM. But I have already installed Scala on the Intellipaat VM. So Scala is already here. And one interesting thing about Scala is that you can work with Scala through an interactive shell, meaning once you install Scala, let's say on the Intellipaat VM, you can just type Scala and hit enter. So what I did is I just typed Scala in the command line of the Intellipaat VM. And there is a small error. Don't worry about this. You will not be getting this error. It is something related to my VM. But the moment I type Scala, what happens? You will be getting the Scala, what you say, interpreter. So Scala has an interactive shell where you will be able to type your code and execute. This is very interesting, right? Because if I want to quickly write a program, I can just open this Scala interactive shell and start typing my program. And the first thing that I want to understand, that I want you to understand, is how Scala treats your data. So I'm going to do something, just pay attention. I'm going to just type the number 2 and hit enter. And then I'm going to type the number, let's say something like 10.3, hit enter. Then I'm going to type a letter, let's say A, hit enter. Then I'm going to type a string, let's say something like Intellipaat, and hit enter. Do you notice something? I believe yes. So when you type, let's say 2 and hit enter, Scala automatically assigns a data type to 2. Scala says, okay, 2, that is an integer. And when you say 10.3 or 10.3 and hit enter, Scala says, okay, you have a number called 10.3. I think the data type is what? Double. And when you type something like a single letter, Scala says it's a character. And when you type a string, Scala says it's a string. So what is happening here? Scala can dynamically or automatically figure out the data type of anything that you provide. So this feature is called dynamic type inference. Dynamic type inference. So what is dynamic type inference? Scala can automatically assume the data type of anything that you provide. So this can be numbers, this can be string values, but whatever you supply for any variable, Scala is able to automatically come up with a data type. You don't have to declare it. Scala can automatically figure out. And you may be wondering, what is this RES0, RES1, RES2, and RES3? Well, you're just providing a value, you are not giving a variable name. So Scala is creating a variable by itself. So this is called result 0, result 1, result 2, result 3. So what is this result variable? Basically, these are system generated variables, right? Uh, this is created by Scala automatically. Because normally when you declare a variable, what will you do? You will say a equal to 2. This is how you declare a variable, right? You will say a equal to 2. But I'm not saying a equal to 2. I'm just saying 2. So Scala is assigning this number 2 to a system generated variable called result 0. So don't worry about it, because in the normal programming, we will be creating our own variables and assigning them. But this is the reason why you are getting this RES0, 1, 2, 3, etc. So first thing about Scala, it can dynamically understand the data type. Okay, fine. The second thing about Scala is Scala supports two types of variables. So when you want to declare a variable in Scala, so usually variables are the first thing you learn when you learn any new programming language. Scala supports two types of variables. One is what we call the immutable variable, it's the val. Second is what we call the mutable variable, that's the var. What is this? What are you talking about? So when you want to declare a variable in Scala, you need to either declare it as a val or a var. How? So let me show you an example. I can just say val a equal to Intellipaat. This is how you declare a variable. You cannot say a equal to Intellipaat. You say val a equal to Intellipaat to initialize the variable. First time when you are declaring. So Scala says, okay, I have understood that there is a variable called a, and this is string, and the value is what? Intellipaat. No problem. Now let us try to modify the value of a. So a is already declared. I'm going to change the value. I'm going to say a equal to, let's say, Spark. The moment I do it, I'm going to get an error, reassignment to val. So val is what we call immutable variable. Once you declare a variable as a val, you will never be able to modify the value of that variable. So what is the value of a? Intellipaat. And what is it going to be? Intellipaat. You can never change the value of a. So whenever you declare a variable as a val, this is called immutable variable. Immutable, like the name suggests, is a variable where you won't be able to modify the value. On the other hand, there is another type of variable which is called mutable variable. An example will be the var or var. So I can just say var, say z equal to 100. So as you can see, Scala says, okay, z is the variable, the data type is integer, the value is 100. Fine. Now I can say z equal to 200. This is going to work because I have declared z as a var or a var. So Scala gives you this flexibility to declare your variables either as immutable or mutable. That is your choice. Where will you use it? That is your choice. Scala has the option. You have a choice. Do you need a mutable variable or immutable variable? Well, this is not something very new or something. If you go to Java, Java has this final variable and non-final variable. So this is a very similar concept that we have here. However, there is one thing that you have to make a note of. So I have just declared this z as 100, okay? Then I modified the value of z to 200. Now, let's try to modify the value of z to Hadoop. So I'm going to say the value of z is now Hadoop. And if I hit enter, I will get an error. Why am I getting the error? It says type mismatch, found string, required integer. So the message is loud and clear. Var will allow you to modify the value. We know that. However, you need to ensure that the data type matches. This is called static typing. Technically speaking, this feature is called static typing. Static typing means once you declare a variable and it is bound to a data type, unless you cast it, you will not be able to modify it. So to put it in very simply, when you initialized z for the first time, it was an integer. That means I can change the value of z to any number that is integer. So from 100, I change to 200. No problem. But I cannot change the value of z to a string value because my original data type is integer. So you have to be careful with this. Whenever you say var is mutable, this means you can modify var, but you have to ensure that the data type remains the same. Now, if you really want to modify the data type, you can typecast it. That is a different concept. But by default, this is how Scala is going to behave. So Scala is an interesting language, so to speak, right? So many of these concepts might be new to you. I mean, we'll try to slowly learn it. I will also be sharing you some extra material, a book on Scala and assignments so that you can practice. Now, the next concept in Scala is what we call block expressions in Scala. It's called a block expression. What is a block expression? A block expression is very easy to tell. So it is something like this. You will normally write a code block, right? In these flower brackets. So if you're familiar with the programming languages, you have this flower brackets and you will be writing something inside that. That is basically what you call a block expression. And Scala also supports block expressions, but there is a slight difference here. To give you an example, uh, I can try to do something like this. I can say I have a variable called add, and I can open and close a block expression. And here I can say, let's say a equal to 10. Then I can say b equal to 20. Then I can say a minus b, a multiplied by b, a plus b. So this is an example of a block expression. You can see that I have written something inside a chord block. A very simple logic. I said A is 10, B is 20, A minus B, A multiplied B, A plus B. What is interesting here is the last expression, A plus B, is evaluated and assigned to this variable called add. What is the value of add? 30. How come add got the value of 30? Because in a block expression, I can create a block expression and assign the value of this expression to a variable if I want. And when I do that, the last part of the expression will be calculated and assigned to the variable that I'm declaring. So it may be probably calculating A minus B and A multiplied B by B, but the value of this guy is going to be A plus B. Now, this is a very simple example. In the real world, you can actually have a very complex code inside a block, and the last statement can be the value which you can add to this variable. So just be aware that you will see something called a block expression. And in a block expression, always look at the last part, and that is going to be the value of this variable called add. Just be aware of this. So this concept is called laziness in Scala. It is called laziness, lazy evaluation. There are many names for this concept. I would like to call it as laziness in Scala. What do you mean by laziness in Scala? So let me show you an example so that you can understand what is laziness. So I'm going to write a piece of code, and there is something called paste mode in Scala. You can just type colon paste and hit enter. So when you type this colon paste, Scala will tell you entering paste mode. You can copy paste multiple lines of code here, or you can type them, uh, and Scala will execute them all together. So that is the paste mode. I'm just going to write a small program. I'm going to say x equal to, let's say, print foo, then 10. Then I'm going to say print, let's say bar. Then I'm going to say print x. I will copy this code so I can reuse it. So have a look at my code. Very simple. I'm declaring a variable called x, and this is a block expression. You know that what is going to be the value of x? The value of x is going to be 10. Because the last statement in my block expression is 10, so x is going to get the value of what? 10. Then I'm going to say print bar print x. Now, if you want to execute these 3 lines of code, you can see the suggestion here, Control D to finish. So I'm going to press Control D. Scala will execute it. You are going to get the output, which is foo bar 10. If you are wondering how are you getting foo bar 10, since there is an explicit print statement, this will be always executed. So wherever you have a print statement, that is going to be executed by default. So that is why you are getting this foo here. And then obviously you're getting the bar. So you're getting the bar. And when you say print x, the value of x is going to be 10. Scala is printing 10. So this is something which we can understand. This is not what I want to show you. I'm going to rewrite the program in a slightly different way. So I'm going to go to the paste mode again, and I'm going to write my program. But this time, I'm going to add a keyword called lazy. So I'm going to write the program again and I'm going to execute the program. But this time, the only difference is I added a keyword called lazy. Okay. And you can see the output is different. Previously, I was getting foo bar 10. Now I'm getting bar foo 10. What is this? What is happening here? And what is this lazy thing that you have written? See, there is a concept called lazy evaluation. You can declare any variable as lazy in Scala. So in this example, you can see that I'm declaring the variable x as lazy. You just need to add the keyword called lazy at the beginning. It will be declared as lazy. So when you declare a variable as lazy, what is going to happen? The initialization of this variable will be delayed. Scala is not going to initialize this variable at all. So that is the reason when Scala execute this line, Scala will figure out, okay, this is lazy. I'm not going to execute this line. So the first thing that it prints is this bar statement. You can see bar. And when you call this variable explicitly within your program, then it is going to initialize the variable x. So then when I'm calling x, it will initialize this variable. You get foo and you get 10. So using this lazy feature, what you can do is you can delay the initialization of a variable. So whenever you say lazy in front of a variable, what will happen? This variable will not be immediately initialized. Scala will kind of like delay the initialization. And when you call this variable in your program, that is when the variable will be initialized. That is why you are getting the output like this. Now, the Scala interpreter or the Scala interactive shell allows you to write a code and execute it, right? And that's what you're doing. You're typing something, Scala is executing it. In fact, behind the scenes, there is a compiler, the Scala compiler, which takes all that you're writing, it's compiling and running and showing you the output. That is what is happening even if you're using a command line based, what you say, shell, Scala shell, right? And one way to write Scala programs might be using this Scala interactive shell, but this is not the popular choice when you want to develop programs in production. So let's say somebody want to write a Scala program in production and they want to run the program, then using this Scala command line shell is not the right choice. Scala also supports what you call an IDE. There's something called IDE. Many of you might have heard about it. It's called an integrated development. Spark is a completely new subject for many people. See, when you write a program, so we are going to write a program, and whenever you write any program, okay, usually what happens, I'm not talking about Scala programs or Java programs, any program you write, and if you want to execute, usually there will be two parts of your program. So when you want to develop a program, let's say a Scala program or a Java program, any program, typically we say there are two parts of your program. One is what you call driver. Second is what you call business logic. This is a very common thing. Any program you write, typically the program will have something called a driver and business logic. What is this? See, the business logic will be the actual code you are writing to get the output. Probably you want to write a program to find out the top 10 products sold by your company. So that is going to be the business logic. The business logic can be a SQL query, it can be in Scala, it can be in Java, Python, whatever. But what you need to understand is there is a part of your program called driver. Driver is this part of your program which contains settings in order to run your program. How many of you have gone through MapReduce classes? If you look at a MapReduce program, let me show you a MapReduce program. A sample program, okay? MapReduce. Yeah. So this is the MapReduce program for word count. Don't worry about the program. See, in this program, this is my MapReduce program. You can see I have a public class, then I have a mapper class. This is my mapper logic. Then I have a reducer class. This is my reducer logic. So this is what you call your business logic. Your business logic basically means what is the logic you want to implement. So if you're writing a MapReduce program, what is there inside your mapper code and what is there inside your reducer code? That is the business logic. But do you see this? What is this? What is this? This is driver. This is very important to understand. This is called driver part of your program. So in here, you can see something called public static main. So this is a Java program. So in the Java program, you're declaring something called a static class, and there is something called a main method here. Most of you have seen this. And I don't know whether you have asked in the MapReduce class, what is this? But this is your driver. Why do you need these things, by the way? The main method is the starting point of your program execution. That is why you need a main method. And as you can see in the MapReduce, my main method can accept arguments as a string array, probably. You also have something called a static class in the MapReduce program. So a static class, the purpose is there can be only one instance of this class and you don't have to explicitly create it. The moment you call it, it will be created and you will not be able to modify the content. That's the most important thing. So once you declare your static class and main method, below that, what do you see? You see your configuration setting, you see the name of the classes, you see your input format, output format, are you using compression, are you using serialization, all these settings. So basically, all the settings you need to run your code is part of the driver. I hope this is clear. So whenever you write a program, the program will have two parts. In a MapReduce program, mapper and reducer is the business logic. But in order to run this mapper and reducer, you need a configuration object, you need the class names to be declared, you need the input format, output format, blah, blah, blah. These all things you will be adding as part of your driver. And when you are writing a Scala program also, it follows the same technique. So let's try to write a simple Scala program to get started with. So what I did, I have just started Eclipse and it looks like this, the Eclipse window. And what I'm going to do in Eclipse is, I'm just going to go to this file menu. I'm going to say new. I'm going to say Scala project. Now, many of you might have Eclipse already installed, but that will be having only Java support. You can add the Scala support, but what I will recommend is download this anyway, right? See, rather than going to adding the Scala support, what I recommend is, download the Eclipse for Scala. There is no harm in doing that, okay? So you just need to go to File, New. I can go to File, New, and Scala project. I can click on the Scala project. And I can give a name for my project. For example, I don't know what to call. Let's call it as May weekday, something like this. Any name will do. And as you can see, a project directory will be created here called May weekday. And if you want to write a Scala program now, you need to declare two things. One will be your static class. Like you see in the MapReduce program, you need a static class and a main method. Inside the Scala programs, typically, we do not use the concept of static class. Instead of a static class, we use something called a singleton object. So a singleton object is nothing but a static class. So I will write it here. Instead of static classes,
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and Dataframe? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
Scala has something called singleton object. See, the idea is same, only the name is different. So normally in all programming languages, you will say static class. In Scala, this is called a singleton object. So what I'm going to do, this is the project I created. I'm going to right click the source. I'm going to say new. I'm going to say Scala object. Now, don't get confused. I'm not creating a class and object here. This Scala object that I'm creating is like your static class. It's called your singleton object. So I can just say Scala object and give any name. Let's try to create a simple if else loop. So as you can see, it says object if underscore else. So here object represents your static class. This object is nothing but your static class. This is same like writing public static, in Java terms. And now I can define a main method. So I can say def. I want to define a main method. And the main method can take arguments as an array of string values. And now you will be able to write your code inside this. So this is the minimum driver code you need in order to write a Scala program. You need to declare your singleton object. That's nothing but your static class. Then you need to declare your main method. That is the entry point of your program execution. And now you will be able to write your code. So let's start with this control structures, right? So normally in every programming language, you have this control structure, the loops, if else, for loop, while loop, etc. So I'm going to create a simple if else loop here. I'm going to declare a variable called fruit, and I'm going to say the value is apple. And I'm going to say if the value of fruit is apple, print red, else print no color. Maybe a bad program. I, I just created it on the fly. I never thought about what should I write. Maybe a bad program, but I think it does the logic. So we are creating a simple if else loop. So there is a variable called a fruit and the value is apple. And I'm going to say if the value is apple, just print red. If it is not, please print no color. So how do you run this program? Very simple. Right click the code, and say run as Scala application. When you run this, say okay. You get the output red. Here you can see the output is red. If I change this to, I don't know, grapes, save it, try to run it, you see no color. So this is now rocket science, very easy to understand, simple if else loop. Now, if you are absolutely not able to understand anything, right? I'm quite sure you will be able to understand this logic. This is the if else logic. But if you're absolutely not able to understand anything that I spoke about these two things, just understand this is like a template or a boilerplate code you need to write any program in Scala. Minimum driver code that you require. So yes, we wrote our first program, the if else loop, so to speak. Not a great program probably, but you know, something. I have written couple of programs and I will share it with you. If you go here, let's look at another if else program. This one. So this program is a little bit more interesting because in this program, what I'm trying to do is I'm trying to calculate the grade of a student. So there is a variable called x. This represents the mark of the student. Um as you can see, this x is having a value of 10, right? So the mark of the student is actually 10. Okay. And then I'm saying if the mark is greater than 80, the grade is A. If the mark is between 65 and 80, grade B. 50 and 65, grade C. Otherwise, grade D. Finally, fail. So you can create a series of conditions using the if else statement. As you can see, I'm using this else if condition here. So normally you say if and then else. You can also use a else if condition to catch more conditions like this. So you can see that I'm saying that, okay, what if the mark is falling between this and this? Then what is the answer? So in that way, you can create this. And if I try to run this code, what should be the output? Just a minute. I'll just try to run this code. Run as, come on, Scala application. So when it executes, what do you get? It should be fail because the mark of the student is what? 10. So since the mark is 10, this will be what? Fail. Okay, so let it run. I think my Eclipse got stuck. Yeah. So the answer is fail, right? So I will share these more examples with you, don't worry. And Scala also supports other type of control structures. For example, I can try to create, let's say, a while loop. So there is something called a while loop. So I'm again going to create one more program. You will say new Scala object. I will call it as while loop. Okay. And I can get the main method from here. So these two lines are going to be common. How do you declare a while loop? A while loop checks for a condition and then prints it accordingly. So I can say something like while, I equal to 10. Sorry, I can declare a variable first. I can say var I equal to 10. Then I can say while the value of I is more than 0. What should I do? Print hello plus I. Okay. And then I can say I equal to I minus 1. So what is this code doing? Uh, while the value of I is more than 0, right? What are you doing? You are printing hello and the value of I. And the initial value is 10. And I'm going to subtract this during every iteration. So ideally, this should print like 10, 9, 8, etc. So let's try that. I will save it. So when I execute, as you can see, you are getting, 10, 9, 8, 7 up to 1. So very simple while loop, just an example. Let's also create a for loop. So there is something called a for loop. It is supported in Scala as well. Let me try to create a for loop. I will say new Scala object. Let's call it as for loop. And a for loop is where you give a condition, right? And try to print. I can just say for I in the range of 1 to 10. What should I do? Println I. So this is probably the simplest for loop that you can write. Okay. So as you can see, it is a for loop. And let me first run it, then explain the logic. Yeah. So this basically prints numbers what 1 to 10. But you may be wondering, what is that you have written here? Because normally in other programming languages, you will say I equal to 0, I plus plus, etc. But here I have written something different. First of all, what is 1 to 10? This looks like English, right? When you say 1 to 10, it looks like English. So this is a beauty of Scala. Scala supports many collections. So when you say 1 to 10, Scala is going to generate numbers from 1 to 10, and it is going to store it in a collection called range. So you can just see this in the Scala shell. If you go to the Scala shell, you can just type 1 to 10. What will happen? If you say 1 to 10, Scala says scala.collection.immutable range. So basically, you will be generating a range of numbers. I can also say 1 to 50. I get numbers 1 to 50. So using the for loop, I'm just iterating through this collection and printing every number in the collection. That is exactly what's happening here. So I can take values in this collection 1 to 10, and you're just printing I. That is basically the logic. So Scala supports if-else loop. Scala supports while loops. It also supports for loops. It even supports do-while loop. All the regular control structures are supported in Scala. So let's first talk about functions. What is a function? A function is nothing but a reusable piece of code, right? So what I'm going to do, we need our IDE, right? And let's also add a main method. And now, um, what function are we going to create? Let's create a very simple function to add two numbers. So the way you do this is you will say def and you will say add. So add is the name of the function. And when you say you want to add two numbers, you need to mention them. So I'm going to say that there is something called A, which is integer, and there is B, which is integer. So these are the two parameters that I'm passing. And then I'm also mentioning the return type. That's again integer. And now within the brackets, what I can do is I'm just going to declare a variable called sum to 0. And I will say, hey, sum is nothing but a plus b. Then I'm going to return sum. And how do you call this function? You will just say print, and I will say sum of numbers is plus add, let's say. So this is a simple example of a function, and we will look at some more different type of functions. But if somebody asks you, hey, what is the basic structure of a function? It might look like this. So you will have the name of the function, and this particular function is taking a and b as input parameters. And what am I doing? I'm just initializing a variable to 0 within my function, right? And then I say this variable is nothing but a plus b, and then I'll just say return sum. I don't have to write it like this. I can just say return a plus b. That will also work, right? So, but this is probably the, how do I say, proper way of writing a function. And you will be calling the function like this. So I have a print statement where I say sum of numbers is, and this is the function. I'm passing 4 and 12. And let's try to run this as well. So I'm just trying to run this. Yeah, so you can see that the output is 16. So no price for guessing, and this is a very simple example. But one thing that we can do with functions is, in this simple example, what will happen if I pass, let's say, only one parameter? So I'm going to say that, okay, add is my function, and I will be passing only one, parameter, one number, basically, 4, right? So I'm going to say that, okay, I want to pass only 4. So in this example, you can see that you're getting an error, right? It will say not enough arguments for this function called add. Because my function add, right? You know, basically when you declare only 4 here, what is happening is your function is kind of like complaining, saying that, okay, there is only one argument, right? So this is not going to work because my function says I need A and B. Okay. So in this example, or what will happen if I call the function without passing any parameter? I'll just say add, and I'm not going to pass any parameter. Again, you will get error. So why are you getting error is because this A and B are not having any value. So just like any other programming language, you will be able to initialize the default values for these parameters. For example, I can say A is a parameter and the value is 100. Then B is a parameter and the value is, let's say, 200. So what am I doing here? I'm saying that, okay, if somebody provide the value for A and B, please take it. If you don't get the value of A and B, use the default values 100 and 200. And now what is going to happen? I'm just calling this function, but I'm not passing anything here. And if I try to run this, you can see the answer is 300. Why 300? Because you are not passing any value, but 100 and 200 are the default values, so you get 300, right? Or if I just try to pass one value, let's say 50, if I try passing 50 as a value, A will be my 50, B will be 200, and if I run this, it is 250 now because the first parameter will be 50 and the second one will be 200. So you are going to eventually get what? 250. Now, if you want to pass a parameter, but it has to be b, you can just say b equal to 50, right? I can say b equal to 50. So now what will happen? The first one will be 100, second one will be 50, you will get 150. So these are just, how do I say, some of the ways you can handle the default values in function. Ideally, you will be passing something here when you call the function. But in case if you do not have anything, you can say, 100 or 200 or any values and then make use of it actually, right? And immutability is a core feature in functional programming. So this is normally how you write a function, right? This is normally how you write a function. And this is a very simple function. It says a plus b. What if I want to write it in a very plain format? I don't want to write these many lines. The first thing I'm going to do, I'm going to delete the return type. I'm going to get rid of the return type. Okay. Also, I'm going to get rid of the return statement. I don't want the return statement. Then I'm not going to initialize the variable as well. I don't need a variable. Probably not required. I'm just going to say what? A plus B. Look at it. Look at the definition. And I don't even need these curly braces. So all you need to do is what? This. Look at the function, very minimal, right? So you can even write it like this. Only thing, your logic should support it, in the sense now I have a very simple logic where it says a plus b and it is going to work. So since I removed the return data type, Scala is going to guess what is going to be the data type of a plus b and assign it here. And now if I write it here and run it, it's going to work. So a return statement is optional. You can avoid it, right? Also, you can try to, how do I say, ask Scala to guess the return data type, right? What is pass by value? Yes, pass by value is a technique where, you will have one function passing the value to another function. So in this example, I'm calling the exec function, but exec function requires your t, right? Exec function requires what? T. Where is the t? The t will be generated by the time function as a value and passed to the exec function. That is why you have written it like this. So for exec function to work, you need a t, and the value of t will be generated by the time function. And if you look at the output, you can actually see that, because first the time function will be executed. That is why this is the first line it executes. Print in time function. You can see in time function. Then the time function is going to return the current system time in nanoseconds. That will become the t here. Are you able to understand? The time function will return the t, the current system time. That becomes the t for the exec function, this value t. So then what will happen? The exec function will say, okay, enter exec function. You can see enter exec function. Then it will say the time is whatever t. You can see it is printing the time. It got the value from time function. Then it says calling t again. You can see calling t again. Then it'll return the t that will go to the main function call. That is what it prints here. Where is call for time function? Here. Here is the call. Here is the call. You have to call it, otherwise it will not work, right? So when you say print, let's say exec function, you are passing the time function within the exec function. So if you write the code like this is an example of what you call pass by value, because you will run one function, take the value, pass it to another function. There is also something called pass by reference. I will show you an example for that, right? The return value is basically correct, the object of time function, right? And that value is being passed to the exec. So the exec basically requires what? An input parameter, right? Exec function says, okay, I need a parameter that is t. No, I don't think the return value is an object of time function. No, I don't think it is an object. It is a value, right? I don't think. Oh, long object you are saying. Yeah. Okay, okay. Yeah, correct. So long is object. But it is a wrapper, like you are saying, right? So this long is object and it is a wrapper. So when you define your exec function, this input parameter that you see, right? It can read from a wrapper. So if you go to the definitions of functions in Scala, right, and if you look at the parameter explanation, the parameter can be a primitive. The parameter also can be something which you can read from an object, which can be part of an object. So here that is what is happening. Because when you are returning this current system time, right, this basically becomes the long, and long is an object like you said, but my exec says this t that you're passing here, this can be either a very primitive, like a number that you're passing, or this can even read from a wrapper that you are getting from the time function, right? So that way, it is actually handling the value, right? So as you can see, now what is happening is that you're basically passing a value, right? Uh, who is this Manasi? Which one would be executed first, exec or time? See, in this example, time is first executed, Manasi. As you can see, look at this line, in time function, and that is actually coming from here. Because you first need the time function to generate a value, then only the exec can be actually used, correct? No, the time function. Yeah, exec need this value from the time function, right? Then only exec can run. So the first thing is the time function gets executed. Why I'm saying is in function exec, you are referencing t by reference, not by value. No, this is by value only, Ashwin. I'll show you how you reference by, how do you pass it as a reference. Maybe I will show the same example, Ashwin. So let us try to use this for a reference now. So now I'm using this for a value, right? Now I'm using this for a value. And how should I use it for a reference, right? Hey, Rupak, debug feature, we will see. Okay, probably offline. Let's complete the topics and we'll discuss about debug feature. Okay, debugging is there. You can run this in debugging mode. Any of this code, you can run it in debugging mode, and that will probably show you suggestions and corrections and all, right? So the same program, so there are two features here, right? Pass by value and pass by a reference, right? So what we discussed right now is something called pass by value. There is also something called pass by a reference. I think, Ashwin, you were a little bit confused here, or correct me if I am wrong, okay? Because I think you were referring to the declaration of exec. So if you look at exec right now, exec says, okay, I'm going to accept an argument called a t, okay? And you can actually change this declaration. So what I'm going to do here, I'm just going to change it like this. So there is a small change here. I don't know how many of you are able to, how do I say, understand the change. So previously, what happened, the code was like this. So here, t was an input parameter and the data type of t was long. Now I just made a small change here, okay? And what is this that you have written? So this basically means exec can refer to any function t which returns long. Correct? So this is basically the signature of a function that you call. Correct? So now what you're saying here is that, okay, you have the exec function, but the exec function is no longer looking for a value. The exec function is looking for a function called a t that returns long. And here you can see you are calling this time function within exec function. If you look at the time function, what is the format of the time function? The time function does not accept any input parameters. The return type is long. So this is how you tell exec function to refer to another function. This is pass by reference. So when you use pass by reference, right, you are referring to another function. And look at one more thing. Let's run this once more with pass by value. I'm going to run this once more, okay? So I'm again going to use pass by value. I'll run this and we get the output. If you look at the value of time, which was printed in your code, so you are printing the system time in two different places, right? And you can see the value is same. Why the value is same when you're printing the system time in two different places? The answer is when you use pass by value, a value is returned and the same value is reused wherever you print it. So the time function was running and this was returning a value, and this value was printed here.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD. B. Data frame. C. Dataset. D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Also here. So as you can see, the system time remains the same. There is no change in the system time because in pass by value, you take one value and reuse it. And now what I'm going to do, I'm just going to modify the code like I said. So now the exec function says, okay, I'm going to refer to any function t which returns long. And how does the exec function knows that it has to refer to time function? Because you're actually passing it here, right? So here you're passing the time function, and the signature of this time function actually matches this. Time function is a function which returns long. And now if you run the same code, see the difference. I'm going to run the same code. You will see the output is totally different. Why the output is different? Of course, the execution will start from here. And now when you go to the exec function, the exec function will understand that it is a reference. So it is not going to do anything. The first line that gets printed is enter exec function. So you can see here, enter exec function. That is the first line. Then when you say print time is t, please understand t is not a value here. T is not a value. T refers to the complete time function. So when you say print time plus t, the whole time function will be invoked. That is why you see in time function, then whatever time that is passing. Then you will say calling t again. You can say calling t again. Again, when you say return t, t refers to the complete time function. That is why again it will say in time function and whatever is the value. So as you can see in the pass by reference example, you are printing the system time in two different places and the values are different. So this is ending with 286300. This is 352100. So the system time is actually different. So the point to be noted here is that how do you declare that a function can refer to another function? So if you want exec to refer to another function, you need to provide the signature of the function. So this is what you call the signature of the function, meaning you are saying that let exec refer to a function called t, which returns long. This can be any function, but the time function actually matches our definition. So we are passing the reference here. So when you do this, the point you need to understand is whenever you say t here, t represents the whole time function. Whenever you are calling the t, the complete time function will be invoked. And that is why every time when you try to print t, it says println, then it's going to give you the current system time. Well, these are just examples to give you an idea about pass by value and pass by reference, and that Scala supports all these techniques. So, what are the things we discussed? We talked about a regular function, okay, and then we talked about pass by value and pass by reference. And I will introduce uh, one more thing, and we will talk about this in detail in the Spark class. I will just introduce one more thing, which is nothing but higher order functions. Higher order functions. So higher order functions are something, I mean, they are a speciality of your functional programming, right? What is a higher order function? A higher order function is any function which can accept another function as an input argument. Now, this is not passed by value or passed by reference. Probably what I can do, I can use the Scala shell to show you an example. So I have Scala also installed on my Windows. I think wherever you have it, it is fine. You can use it on the VM or you can even install it on Windows. So I have my Scala shell, right? And let's take a simple example to understand this. What I'm going to do, I'm going to create a Scala array. I know that we have not discussed array so far. So array is a collection in Scala. There is something called array. What is an array? Array is nothing but a collection. Collection means where you can have group of elements, right? So you have numbers 1 to 7, and I'm declaring that as an array. And we will see arrays later. Don't worry about it, right? So here you can see if you type S, what will you get? S is an array of numbers 1 to 7. Now my requirement is I want to multiply each element of this array by 2. So I need the output like this. For example, I need the output which is like array, let's say 2, 4, 6, 8, 10, 12, and 14. So this is the output that I expect. So my original array says 1, 2, 3, 4 up to, 7, right? But then I say, okay, I want to multiply each element of this array by 2. This is basically what I need, right? So here, as you can see, we have an array of numbers, and the numbers are 1 to 7. And my requirement is I want to multiply each element by 2. As you can see, the expected output is like 2, 4, 6, 8, 10, 12, and 14. So normally when you want to get an output like this, okay, what you do is you will probably write a for loop or something. You will say, okay, for each element, I will say multiply by 2. And that is the usual way of writing the code, right? You will say, okay, I have an array. Let me write a for loop. Let me iterate through each element and multiply each element by 2. That is usually what you do, right? But now what I'm going to do, have a look. I will show you this in two ways, okay? The first way is I'm going to declare a function. I'm going to say def. I'm going to call a function called doubler, and this will accept something called a. Okay, the return type is also a. And in this function, I will just initialize a variable called, let's say, d to 0. Then I will say d equal to, let's say, a multiplied by 2. Then I will say return d. Very simple function, right? So what am I doing here? I'm just creating a function called doubler. And what is this function doing? It has something called a as an input, okay? And this is going to multiply a by 2 and return this. Very simple function. And now what I'm going to do, I'm just going to say s dot map, and I'm just going to call doubler. So first things first, you got the output. If you are wondering, how did you get the output? Okay, some of you might know this, but I assume the majority of the class doesn't know this, right? So what happened here is I have used a function called map. Map is an example of a higher order function. In fact, it is a built-in higher order function. Okay, map is a built-in higher order function. What is a higher order function? A higher order function is any function which can accept another function as an input argument. Now, map has a logic. Map is going to internally run kind of like a for loop. So you don't have to write it because map is already there. Map is part of your Scala. So when you call the map higher order function, what is going to happen? Map is going to internally run a for loop. Okay. And then it is going to use this doubler function internally. So what the doubler function does, the doubler function says, okay, you give me a number, I will give you the double of that number. What map is going to do, map is going to take this logic and apply that to every element of your array. So basically, every element of your array will be passed to the doubler. Eventually, every element will be multiplied. So this is a simple example of what we call a higher order function. What is a higher order function? Any function which can accept another function as an input argument. Now, I'm not talking about pass by reference or pass by value. They are different. In pass by value, you get a value and you constantly reuse the value. In pass by reference, you are just referring to the function and getting the value from here. In higher order functions, what happens, the whole logic of this doubler function can be used inside another function. So map is a built-in higher order function. There are lot of built-in higher order functions in Scala. And if you want, you will be able to create your own higher order functions as well. What is the advantage of doing this? See, the advantage is I could have written a for loop also for multiplying these numbers. So if you have only 7 numbers, and if you just want to multiply them, even writing a for loop is fine. But if your data is huge, okay, if your data is huge, and let's say you're talking about big data, right? And in those scenarios, first of all, writing a loop and then iterating and then generating the output is probably not practical. It is also time consuming. So these higher order functions, most of them, the built-in higher order functions, they are pre-compiled. So this is going to be faster because the logic is already built in. So all you need to do is you need to pass the logic. So in my simple example, the logic is multiply by 2. And then map is going to take that logic and apply that to every element of your collection, that is array. But there is one thing here, this doubler function, when I wrote the doubler function, you can see that it is a very big function, right? I said DEF, then doubler, then the return, then all these, different lines. But all I need to do is multiply by 2, right? All I wanted to do was I wanted to multiply by 2. To do that, I wrote a very big function, called doubler and all. So this is where you can use another concept called anonymous functions. There is a concept of anonymous functions. We have something called anonymous functions. What are anonymous functions? Anonymous functions are functions without a proper name or declaration. To give you an idea, if I want to get this same output, what I can do, I can say s dot map. I can say for every I multiplied by 2. So have a look at this. You got the output, but what did you write here? So this is what you call an anonymous function, right? An anonymous function is, how do I put it? An easy way to write your functions. So if you want a function which can be used only once, let's say you want to write a function on the fly, you don't want to reuse it, and you also don't want to spend a lot of time writing the function, you can actually use an anonymous function. So anonymous function will be very simple. There will be an input, there will be an output. So here it says, if the input is I, output is what? I multiplied by 2. That's it. So there is no name for the function, definition for the function, or anything. So anonymous functions are also like regular functions, and you can pass them to higher order functions. If I show you one more example, you will understand. Let's create another array. So I'm going to create another array. So this time I'm going to have an array of, let's say, string values. Raghu, Hadoop, Hive, let's say pig, let's say MapReduce. So I have an array of string values, different string values. I can say f.map, then I can say take every element, and I just need the length of each element. So can you see what happened here? First of all, map is going to take this logic, whatever you wrote here, and apply to every element of my array. Because map is a higher order function, it is going to take this logic and apply to every element. What is the logic? The logic says if the input is I, output is length of I. So if the input is Raghu, the output is 5. Length of Raghu means how many characters are there. If input is Hadoop, output is 6. So you can write your code in a very concise way if you are using these anonymous functions and also higher order functions. I can also do things like this. I can say f.map. I can say take every element and convert to element comma 1. Look at the logic. I says if I is the input, I comma 1 is the output, key value pair. So what happens? Every word is now converted into the word comma 1, like a key value pair. So anonymous functions, we will see a lot of them when we go to Spark and start working. But basically the idea of anonymous functions are to express your logic in a very simple way. And anonymous functions, they do not have a proper name or definition because these are like disposable or use and throw away kind of like functions. So now this is, so when you start writing your code, let's say using anonymous functions, you use features like immutability, higher order functions. That is the functional way. That is the functional way of programming, right? And we will see more examples of writing this. So again, in pass by reference, only thing that we need to understand is that you will have the T, wherever you have the T, the moment you call the T, this entire time function will be executed. That is why the first line will be this enter exec function. That's what you get it here. And when you try to print the T, what happens? The entire time function invokes. So you get in time function and whatever the value that the time function give you. Then you get calling T again. You say calling T again. Then you say return T. Again, this time function is invoked. And then you get the value. So whenever you are, how do I say, referring to the T, your entire time function is being executed, Rupak, right? In this anonymous function examples, right? So remember we wrote like this. I said s dot map, and then I said for every I, oh, sorry, s dot map. Then I said for every I multiplied by 2. Remember we wrote this, and this can be written even in a lesser, shorter way. You can say s dot map underscore dot star 2, right? Underscore star 2, right? Yes. So this is another way of writing the same code which you wrote here. So here you are saying for every I1 I multiplied by 2. So instead of writing like for every I multiplied by 2, you can just say underscore multiplied by 2. So here this underscore is a placeholder. This just represents any element in your data. So instead of saying like, let it be I and then I want I multiplied by 2, you can even reduce the number of lines of code or probably the length of the code by simply typing underscore multiplied by 2. So this just means that underscore here represents any element. It is equal to saying for every I, and then you say, okay, I just want to multiply by 2, something like that, right? So that is what Ashwin was trying to tell me. Apply method, okay. Like lambda function in Python, correct. So this anonymous functions are equivalent to the lambdas in Python. So when you go to Python, right, you have this concept of a lambda. The same thing is actually called anonymous function when it comes to Scala, right? Does underscore follow any order? No, not any particular order, but you will be able to use it even within these nested data structures. And we will see. For example, if I want to access the value within a key value pair, I can do that using underscore. It doesn't have an order. It just is like a placeholder. It just says for each I or for every I in the particular data, right? All right. So we had some idea about functions, right? No, there is no indentation in Scala. Unlike Python, there is no indentation. Uh, Python follows indentation. Scala doesn't follow any indentation. All right. And in Scala, even semicolons are optional. So if you're writing like a code block, you can even get rid of the semicolons and all. Indentations are also not required in Scala, unlike Python. Okay, so since we understood these concepts, at least probably on a theoretical side, we know there is something called function, and pass by value, pass by reference is something which we saw. Higher order functions and anonymous functions, we took example. And when we go to Spark programming, when we start working with Spark, we will be using a lot of higher order functions. And you will see more examples of them when we actually go to RDDs and Spark programming and all. Don't worry about them. And also I will be using anonymous functions. So you will come to know, okay, these are some of the use cases and how do I write it. And now let's talk about something called collections in Scala. What are collections in Scala? Like the name suggests, right? Collections are basically group of elements, right? So we just saw an example of an array. An array is an example of a collection. Why? Because in an array, you can have maybe 100 numbers, 1 million numbers, you hold them inside an array. So that is called a collection. And Scala has many, many collections, right? In fact, if you want to talk about only the collections in Scala, then 2, 3 days will be required only for that. But for our purpose, since we are learning Spark, not all the collections are important. There are only few of them. So there is something called array, array buffer. There is something called map, then tuple, then list. So if you can learn at least array, array buffer, map, tuple, and list, that should be more than enough to get started. Let's look at this array and array buffer first. Okay, and I'm going to use my Scala um, interpreter, the Scala interactive shell, to work with this. So first, let's start with uh, arrays, right? Simple arrays. So the way you define an array is very simple. We have already seen an example, but again, let's say I want to declare an array. I can just say val s equal to array of, say you have some numbers. This is an example of an array, right? And once you declare an array, the speciality of an array, the default array, is that it is called fixed length array. So by default, arrays are called what? Fixed length array. Meaning, once you declare an array, you will not be able to add or remove elements from the array. So I have this array now, and this array has, I don't know, these many elements. I can keep them, but I will never be able to add or remove elements from my array. However, and Scala is a pure object-oriented programming language. Everything is an object in Scala. Even when you declare an array, so right now I have an array called S. This S is an object actually. Everything is declared as an object in Scala. And surprisingly, all these collections like arrays or map or whatever you call, they have lot of built-in methods. For example, I can say s dot sum. So if you just want to do a sum of elements of an array, I can do a dot sum. I can say s dot distinct. So this will give me all the distinct elements of the array. Then I can say, I don't know, many of these built-in. I can say s dot min, probably the minimum one, s dot max. So as you can see, an array has lot of built-in methods you can call. And you may be wondering, from where are you getting this? Like sum, min, max. Is there a list that I can refer to? So you can just say s dot and press the tab key, and you can see all these methods you can run on an array. So just say s dot and press the tab key, and you can see there is ends with, there is find, there is last, there is, I don't know, scan left, there is to array, to buffer. So this is a generic list of methods. Some of them may not work, but most of them should work. So I'm getting this dot sum, min, max, everything from here. So you can see there is a dot sum here, and I was doing this min, I was doing this max, right? And we can also run a map on top of this array. So this is a higher order function we used. So all this help is available if you do a dot and then tab, S dot and the tab. So you can see all these options that you have. Let us also create a string array, D equal to array of, say, Hadoop, Spark, Hive, and Pig. And how do you access the elements of an array? So you can just say D of 0, and this is going to give you Hadoop. So the index position of elements in an array starts with 0. So when you say array of 0, like D of 0, you get Hadoop. If you say D of 1, you will get what? Spark. The second element is what? Spark. So you say D of 1, you will be getting Spark. And you will be able to modify the elements as well. So I can say D of 3. What is D of 3? Pig. And I can say D of 3, I want, I don't know, Kafka. So now if I say D, you can see the last element is actually changed.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and Dataframe? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
So you can access the elements of the array using this index notation, and this will start from 0. And you can modify the elements of the array. However, you will not be able to add or remove elements from the array. That is kind of like the drawback. I won't call it as a drawback, but that is a feature of the array. So if you have an array, you will not be able to add or remove any elements from the array. You can just keep it as it is. But there can be many situations where you need to have an array where you should be able to add or remove elements. So that is where you go to something called array buffer. So array buffer is an extension of the array. Array buffer is also an array, but here you will be able to add and remove elements from the array. How do you declare an array buffer? So first, you need to import this collection, and then you need to say something like this. So first I say import Scala collection mutable array buffer. Okay, so there is a list of mutable and immutable collections. Okay, and when you talk about collections, mutability and immutability is different. For example, array is called immutable. Okay, array is called immutable. But you may be wondering why it is called immutable, because I'm able to modify, right? What is the array you created? S, right? So if you have the array S, right, this is actually called an immutable array. But you may be thinking, okay, I can modify the element, right? Then why are you calling it as immutable? For example, I can say S of 0 equal to 100. I am able to modify. However, this modification is happening within an array. So basically, the default array is immutable in the size range. When you declare an array, this has, I don't know, like say 12 elements, that size of the array is immutable. That is what you mean by immutability in an array. And if you need a mutable array, you can import scala.collection.mutable array buffer. So, and then this is how you declare something called an array buffer. So let us assume you want to create a collection of cars. So you just say cars and you say new array buffer of string. So I'm not adding anything. I'm just declaring the array right now. And if I say cars there will be nothing. And I can just keep on adding elements like this. For example, I can say Audi. Then I can say, let's say I want to add Mercedes. I can add BMW. I can add Volkswagen. I can add Volvo, etc. So as you can see, in a mutable array buffer, you will be able to add elements. Also, you will be able to remove elements. So now I'm adding the elements. The way you access them is still the same. So you can say cars of 0, and this becomes Audi. And if you want to modify, you say Audi. So there is a spelling mistake, right? So I'll say Audi. Okay. So now you can see I have this array buffer called cars where I am able to add elements on the fly. Also, in an array buffer, you can do many things. For example, there is a insert method. I can insert at a particular position. So I can say insert index position 2 Bentley. Also, I can insert multiple elements like this. And now if I say cars, my collection is huge. So when you say insert, you need to mention a position and what you want to insert. So I first inserted Bentley. Then I said, as the second element, I want Fiat, Volvo, Renault. So what happens? You have Audi, then Fiat, Volvo, Renault, right? And then Merck, and then Bentley, then BMW, so on and so forth. So all these elements are added now. And you can also have some interesting functions here. For example, I can say cars dot trim end 1. What is trim end function? This will remove one element from the end. So as you can see, this Volvo is gone. So here it is only Volkswagen. The Volvo is gone. So trim end function, and you can pass a number. It is going to remove those many elements starting from the end. Also, there is a trim start. You can say trim start 1. So now you can see the first element was Audi, and that Audi is gone. So trim start will remove any number of elements from the beginning. Trim end is going to remove any number of elements from the end, right? So you can have all these functions. I mean, you can also say cars dot remove, let's say 2. So there is a remove operation. You can also say minus. Okay. So I think you will be able to say minus equal to Merck. Yeah. So if you want to remove elements, either you can say dot remove and mention a position. So this means Volvo is gone. Okay. Sorry, Renault is gone, right? Because the third element is Renault. Or you can say cars minus equal to Merck. So either you can remove by position or you can remove by the actual value, and then you will be able to do that, right? So talking about, so that is array and array buffer, okay? And now you have something called map and tuple. So what is a map? A map is a key value pair. So if you go to the Python world, you have something called dictionary. So if you are a person coming from Python side, you might have heard about something called, uh, you know, a dictionary, right? A dictionary and a map is very similar. A map is equivalent to something called a dictionary, right? So basically, a map is a key value pair. It's a key value pair. As you can see, this is the way you declare a map. You will say map, and you can say the key is NY, the value is New York, the key is NJ, the value is New Jersey. So here, this is the key and this is the value. That is the syntax of representing a map. And the moment you create a map, Scala says, okay, scala.collection.immutable map. Map is an example of a pure immutable collection. 100% immutable. What do you mean by this? In a map, you cannot add elements, you cannot remove elements, you cannot modify elements. Nothing is possible. Once you declare a map, it stays as a map. And if you want to access the elements of a map, you always use the key. You never use the index like 0, 1, 2, 3, and all. So in an array, we have said 0, 1, 2, 3 to access the elements. But in a map, you never say 0, 1, 2, 3. You always access the elements of a map using the key. Since it is a key value pair, you always refer to the data using the key. What is an example for this? To give you an idea, I can say mapping of NY. This will give you New York. So you can say mapping of and then the key, and this will give you the value. And if you try to modify, you will get error. Value update is not a member of Scala collection immutable map. So definitely you cannot modify, right? And like I said, you cannot add, you cannot remove, you cannot modify. And you can say mapping dot keys. If you just want a list of keys, you will get it as a set. You can even say mapping dot values, I guess. Yes. So you can get the keys and values like this. If you say dot keys, it will give you as a set by default. Set is a collection, and then the values are also printed as an iterable. You can see them, right? But many a times you probably want a map where you can modify the elements. That is where you go to a mutable map. So here, this is an example of a mutable map. How do you declare a mutable map? You can say Scala collection mutable map, right? And then you just declare the map, just like you do it regularly. But the only difference is instead of just map, you say Scala collection mutable map. And now I will be able to add elements like this. As you can see, I'm able to add CA for California, NJ for New Jersey. And if you want to remove them, you can just say minus equal to, let's say, Wyoming. So this part is where you are adding the key value pairs. This part is where you are removing an element from the map, since we have a mutable map. And whenever you want to remove something from a map, you provide the key so that you can remove it. You can also modify. I can say states, let's say NJ equal to my state. So in a mutable map, it's just like a normal map, the way you access it and all, but I can add, I can remove, I can modify. So just be aware of what is a mutable map. Last but not least, we have something called a tuple. So tuples are the only collection where heterogeneous elements are supported. Meaning, if I want to create a tuple, say you say F, you can say Raghu 3.14. This is an example of a tuple. Okay. A tuple is where you have heterogeneous elements. As you can see, so there is no common data type for a tuple, right? The data type is there for every element. So you can see Raghu, it read as a string. This is a double. This is an integer. Double is for decimal, right? So for a tuple, I can keep heterogeneous elements. And tuples are very important. Why? Because when you go to Spark or any other platform, while you are reading and processing data, uh, each line or each record of your data can be represented as a tuple. So let's say you have a CSV file and you want to read and process the file, then each row of the CSV file can be represented as a tuple. That is the use case for a tuple, right? And you know that if you have a CSV file with, let's say, 10 columns, maybe each column is of different type. It need not be the same type, right? So tuples, and tuples are 100% immutable. And there is a speciality of the way you access elements of a tuple. I can say f dot underscore 1. This will give me Raghu. This will give me 3.14. This will give me 20,000. So first of all, the index position starts with 1 instead of 0 in tuple. And you will be using this dot underscore method to access the uh, elements of a tuple. So you normally say dot underscore to get the elements of a tuple, right? This is the speciality of a tuple. And we will see tuples more when we go to Spark. Like I said, when we are reading and processing the data in Spark, uh, tuples are very useful, right? And we will be writing our analysis on key value pairs and tuples and so on and so forth. There is also something called a list. Okay. A list is very similar to an array. H equal to list of. This is a list. And a list looks very similar to an array. Very, very similar, right? I can say h dot sum. I can say h dot max. I can say h dot distinct. I can say h of 0. So all these things are similar. In fact, many people get confused between list and array. The classic difference is in a list, you can never modify the elements. Remember, in an array, you can always modify every element, but in a list, you cannot modify elements. So when you say h of 0 equal to 100, you get an error saying that value update is not a member of list. So what I recommend is you can go to, there are multiple options, right? AllaboutScala.com is a nice place where you can practice all these things what we have covered so far.
What are data frames in Spark? So now that we know what data sets are, data frames are essentially a data set organized into name columns. So data sets are essentially arrays that are unstructured in a way, and when you convert those arrays into a actual table, an SQL table, that table is called a data frame. So it is conceptually equivalent to a table in a relational database management system, for instance, a MySQL or an Oracle database. And it is also sort of similar with the data frames that we create in R and Python. So if you're coming from a data science background, you might be familiar with the data frames that are possible in R and Python as well. But Spark is obviously built for big data analytics, and that is why it is easier to basically analyze big data sets with the use of Spark. So as we can see in the diagram, the data set object, the JVM object, the data set object was once transformed using the map, filter, or flat map function, whatever it was, into furthermore JVM objects. And then by using the simple 2DF function, which means the two data frame function, we converted them into a Spark data frame. So this Spark data frame has named columns and is essentially a very well structured format of data. So we can perform queries on this, SQL queries on this, and basically overall treat it as a structured data set. So the APIs available for Java, Scala, Python, and R. So the data frame API is available for Java, Scala, Python, and R. So if you're even from a Python or R background, you can still use Spark data frames very easily. So now we move on to the data frame tutorial. So I'm going to be using my Linux virtual machine to actually perform this. So let us begin. So currently we are inside our virtual machine and we're going to be performing some analytics on a text file that I have created. So the text file is called YT Live. If I just open it up, the contents, we look at the contents of this text file. So these are the this is the content that is present. So it says, hello from Intellipaat. Today we are going to be discussing Spark data frames. Hello from Intellipaat. So this is the content of the text file, and we're going to be performing some analytics on this. So the first thing that we're going to do is open up our terminal. So I'm going to just zoom this up so you guys can see clearly. So firstly, we're going to be starting our Spark shell. So type in Spark -shell for that. So that will start our Spark shell session. Yeah, so we have created our Spark shell. So right now, the advantage of Linux is it's pretty easy to install Apache Spark because we don't need a multi-cluster system to actually use Spark, and it's a preferred environment because if we are going to do this on Windows, then we'll have to virtualize the concept of a cluster, and it involves a lot of setup procedure. So it's always better if you can just get a virtual machine and then start to install Apache Spark. And then we can begin with our question. So firstly, I'm going to just create a variable to store our text file inside. So I'll call this RD, and I'm going to equate it to sc dot text file because we're going to be analyzing a text file. So we need to import a text file with our Spark context, and our Spark context variable is sc. And then within our brackets, we're going to be specifying the parameter or the address where our text file is. So just open up double quotes and type in the address. So in my case, it's home training and ytlive.txt and then close. So I'm just going to verify whether it's that before I actually execute that. It's called ytlive.txt. Absolutely, it's correct. So now I'm going to begin. And then after that, just simply press enter and it will create an RDD out of that text file. So we're going to use this RDD object and then essentially create our word count program first. So simply create another RDD, we'll call this counts and weight it to rd.flatmap. As we were discussing earlier, we can further transform this RDD line So line is a variable. You can use any variable that you want, but I'm using line to indicate all of the lines that are present inside of my RDD object that contains my text file as a string, and line dot split, and I'll split this line on a particular regular expression. So this regular expression in my case would be double backslash w plus. So what does this mean? So this expression essentially implies that all of the special characters and numeric values present within our text file will not be included in the final data frame that we will create. So it will only give us the pure words, because we are going to be performing a word count, and then we are going to convert that word count RDD, the count that we receive, into a data frame, a structured data set. So that is why we're using double backslash W plus instead of an actual space as our delimiter. So once we are done with that, dot map word, and word is another variable that I've created to indicate words as opposed to lines, and then every word I'll map it to 1. So every word, whenever it occurs, will have the count 1, and then I'll close this up, then type it reduce by key. So map reduce. I'm going to reduce all of these words mapped to 1. Whenever they occur, I'll add all of their values, which is 1. And then given the parameter that I want for this, which is plus sign, because I want to add all of the key values. And then press enter. So that creates another RDD, which, as we can see, contains a string element and an integer element. So the string element is the word, and the integer element is the count associated to that word. All right. So now we will actually create a data frame with the simple 2df function as we discussed. So we'll call this variable df, and we'll convert counts to df, right? Because we need to convert this RDD, this object, this JVM object into a data frame, and press enter. So the 2df successfully converts our RDD into a data frame. So on one column, we will have all of our words. On another column, we will have all of our counts. So we've created it successfully, and now we will now perform some operations on this. So the first thing that we can do is change the column names. So currently, we have _1 and _2 as our column names. If I simply type in df dot show and press enter, then we'll get our table that we have. So as we can see, the column names are _1 and _2, but we need to change these column names into something else. So for that, simply type in another, we're going to create another data frame. We'll call this df2, because you cannot actually change something that is already present. You cannot change an existing data frame. You cannot transform it. You'll always have to create new data frames or new objects, because Spark functions in memory. So whenever you're doing something new, you will create a new copy of that inside of the memory. All right. Okay. So df dot, the new data frame would be equivalent to df dot 2df, because we're going to be converting this into a data frame again. And the sequence of the column names would be word, count, because this is the sequence that I want my column names in. So I'm creating a sequence for that. And then I'm going to replace this, replace the existing column names, which is _*, with this new sequence of word and count. So how does that work? It basically means that underscore asterisk represents both underscore 1 and underscore 2. The asterisk is replaceable with 1 or 2. That is what it means. If you've ever actually dealt with the Linux file system, you will understand that concept. So the word will replace the first, which is our underscore 1, and the count will replace our second, which is our underscore 2, and we will have new column names in our new data frame that we are creating, and we'll press enter after that. So we've successfully created two new column names in our new data frame. So if I simply type in df2 dot show and press enter, so as we can see, the column names are different in this. The first column name is word and the second column name is count, right? So let us do some transformations, or let us do some querying on the data frame that we've created. Now that we've successfully converted an unstructured data set into a structured data set, which is this word and count, proper SQL table, right? So now we can perform some queries on it and see how that goes. So as if you remember, in SQL, we have something called order by. So if I simply type in df2 order by, and if you want something like ascending order, right? If you want all of these counts in ascending order, we can simply use ASC for that. And given the column name count, dot show, and given like we want the first 5 counts, so do that and press enter. So we can see it has been arranged in ascending order. So if we just see this in ascending order, we have a lot of ones, so that will arrange automatically. And that is how we're getting a result. The first 5 results with 1 is what we are essentially getting. And if we want to ascend it, arrange it in descending order, we can simply type in BESC and count, and that would arrange it in descending order as well. So as we can see, the counts have been arranged in descending order too. Data frames also provide us with the filter function, so we can use that as well. So to filter out particular column attributes, if you simply type in df2.filter and given a criteria inside of double quotes, so I'll say count has to be greater than 1. So this is my criteria for the filter. So that's the query that I send in the function's parameters, count greater than 0. So that would go into the SQL context for this data frame, and type in dot collect and bracket open, bracket close, press enter. So that would essentially give us all of the elements present within our data frame that are above the count of 2. So we can also do it this way. If we want to simply see it as a data frame, remove the collect and type in show and press enter. So that would show it as a data frame. So this was showing it as an actual SQL row, but here it is showing it as a data frame itself. So you can use collect and show alternatively depending on the use case that you may have. If you want to send data, then definitely use collect. If you want to display data, then use show. All right. So these were some of the functions that you can use with data frames. There are obviously a lot of functions that are possible because it essentially gives you the option to treat big data as an actual RDBMS table.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Let us now get on to how to access data files. So I'll be showing you a brief hands-on on how to access the data files, and then we'll eventually move on to querying the data files. So accessing a data file is actually quite simple. Simply create a document first, right? So you can do this with the command line as well, but I'm doing it with some visual interface just to tell you guys how it actually works. So let's call this example.txt, right? So once you've created that, you can simply open it up and type anything you would like. So in our case, let's just type hello from Intellipaat. So this is just basically a data file, right? This is unstructured data in a way. There's no order to it. It's just a basic sentence. So if you want to convert this into a Spark JVM object, you'll simply save this first, right? Close this up. So this is also the present working directory that we have. So here is the file. Simply open up a terminal. So this is a terminal. I'll just expand the size for you guys so you can see. Yeah. So there. The first thing that we would do is obviously start the Spark shell, right? So the Spark shell by default starts in Scala. So it is a Scala shell with the Spark libraries already imported. So it takes a bit of time to start up, but it starts up. Yeah. So the Spark session is available as Spark, and the Spark context is available as SC. So this is a variable that we would be using to invoke the Spark context, right? So the thing that you would do is create a variable. I'll call this RDD, right? And equate it to the sc.text file. And given the location for where you want to take your source file from. So in our case, it would be from the present working directory, which is home training, and the file name, which is example.txt, given the double quotes again, and close it up and press enter. So that would create the RDD out of that particular text file. So that is how simple it is to basically take a raw text file or a raw data file and convert it into a Spark RDD. So now we have reached the querying part. So let us see the exact procedure that Apache Spark follows for this data file querying. So as we can see, the way we achieve data querying is by converting the raw data that we have. In other words, the data files that we were referring to earlier. We basically convert them to data frames, and then we run normal SQL queries on them. So the definition of a data frame is it is a data set organized into named columns. It is conceptually equivalent to a table in a relational database or a data frame in R Python, but with richer optimizations under the hood. So to explain that in brief, it basically means that Spark data frames are equivalent to SQL tables, right? The relational database tables, or you could basically equate them to data frames that you would normally create in R and Python with vanilla R and Python, mind you. So it is basically equivalent to that. But the richer optimizations here implies that it is optimized for cluster computing. These are not normal data frames that are present within one system. These data frames could be present throughout multiples of systems on multiples of nodes in a cluster. So, and you wouldn't even notice the difference. You are just seeing it from one point of view where you see the entire data frame in one page, right? So that is the difference between a normal data frame and a, say, R/Python data frame, right? So the procedure here, as we can see, raw data, which could be semi-structured, unstructured, or even structured at times, data, it's first converted into a Spark JVM object, right? So there are essentially two types of Spark JVM objects. Spark obviously uses JVM objects because it is an object-based framework. So one of them are RDDs, and the other is data sets. So you can basically convert them into JVM objects, the data that you have. So these could be arrays and whatnot, right? So once you have these arrays based out of the raw data that you've generated earlier on, you can convert these arrays into named columns, and those named columns are then called Spark data frames, which is our target anyway, right? So once you've converted them into Spark data frames, which are SQL-like tables, naturally you should be able to run SQL queries on it. And Spark actually allows you to do that because Spark provides the SQL context, which means you can pass string values, which are equivalent to SQL queries that you would normally pass in, say, MySQL, and then basically analyze the Spark data frame that you have like an SQL table, and then get your query results as is. So that is how much Apache Spark simplifies analyzing big data. It brings it down so that a normal person who has experience in relational database management systems can use Apache Spark very conveniently without having to learn a lot of new things, right? So these are one of the advantages of Apache Spark, the accessibility that it provides, right? So as we can see on the bottom, Spark SQL context is created to run string-based SQL-like queries on Spark data frames. So as we discussed earlier. So now let us perform some SQL queries using the SQL context that Apache Spark provides on a freshly created data frame. So let us begin. So now let us take an example at a real life data set. So we'll be looking at a comma separated file, a comma separated value file, a .csv file. So this is yellow.csv. So what does yellow.csv have? So in order to give you a brief introduction to the dataset, it's basically a taxi dataset, like a taxi trip dataset. So you have your pickup date times and your drop off times and the total duration of the trip and the total distance of the trip, where the passenger was picked up and where the passenger was dropped off. So all of these things basically, and the distance between all of the trips and the amount, the fare and everything. So you can think about this as a taxi data that has been generated for the well-known taxi apps that you may be using on a regular basis. Well, not these days because of the virus, but in other ways. So Ola and Uber sorts. So this is basically the data that they're generating on a day-to-day basis. So if you just scroll down, we can see that this somewhat qualifies for a big data use case, right? And we're going to be actually running some queries on this data set. So firstly, this is in a semi-structured format, a CSV file. We are going to be converting this into a data frame before actually performing queries on it, right? So let us just quickly minimize this, or you can just close this off as well. Works the same. And open up our terminal, right? So let us continue from where we left off. So open up the terminal and expand this, right? So firstly, we are going to be actually importing our taxi dataset, which is the yellow.csv. Right? So let's create a data frame out of that. So we'll call this data frame df and simply type in Spark, which is the Spark variable that has been created, the session variable, dot read, and that then will give a simple dot format and specify the format of the file. In our case, it's a CSV file. Type in CSV for that. Close that up. Now you can give certain options to this. So we'll firstly give that we actually want the header. So the header is the first row that is present in each CSV file. So we want the header to be there. So we will simply give a header as true. We'll give some other options as well. We want this to be treated as a schema, so we'll do that as well. So this is a simple option for that. And for schema, we'll give this the Boolean value of true. Right, and then simply type in another option. You can keep on typing options, as many options that you would like. So you can, once you would actually start to understand Spark, you'll understand how many options there actually are. And given a mode for memory management purposes, so I'll give this a fail fast mode. And then simply type in the location of the file. So type in dot load and given the location of the file. So in our case, home training yellow .csv and close this up. And once you do that, it will automatically create a data frame out of that CSV file using the comma separated value functionality, and press enter. So it takes some time to load it all up. But once it loads it up, there's no delay and latency after that, because it is essentially loading it up inside of the RAM, right? So let us now continue with this. Firstly, we'll actually not call this the DF. We'll create a temporary view out of this DF so we can refer to it in the SQL context that we would invoke later on. So we would be renaming this table essentially and not calling it DF. This is an optional step, but it's for better readability of code. So it's always recommended. So create or replace temp view. And you can call this anything. In my case, I'll call this taxi data, and then close it up. Press enter, and it will create the new view, right? So after, we are basically referring to it as taxi data from now on whenever we use the SQL context on this particular data frame, right? So say now we can run some queries on it. So let's think of a query. Say we want to find out a total number of trips that have been taken throughout the data set, right? Simple. Simply invoke the Spark session variable, type in .sql. So we are now invoking the SQL context as well. And it's simple as anything. You can simply start a string value or double quotes and type in what you would normally type in MySQL, right? So how would you do it in SQL? Select, and then you will type count. Count is a function in SQL. And star, so you want to count all of the records, so you're typing in star, so all of the rows, basically the number of rows will be counted except the header. And type in from, and the alias that we just provided it earlier, which is taxi data, we'll call it taxi data, and simply double quote close and close this up. And what this will do is basically, and when you type in .show, this will show you the result out of that SQL query. So you will get what the MySQL would have shown you normally. So in this case, for big data, press enter, it will give you the count, right? So in our case, we have about a 10,000 number of records, basically. So we get that. Now, say we want to get a little more complex, right? So now we want to find out the total number of the total revenue that is generated, right? So the total revenue that would be generated from all of this would be the sum of the column, that is the revenue column. So if we just simply see how this is working, if we type in df.show and type in 3, so we want to see 3 records to get an idea of how the columns are working, press and enter. So as we can see, the record that we want to refer to is the total amount, right? So this is the amount. So this particular column, we want to add up all of the values in that and finally get the value at the end of it that we would like, right? That is what we want to do. So let us just simply do that. So we know the column name that we want to refer to. So if I simply type in spark.sql and type in select sum, and then type in the column name that I would like to use the sum for, which is the total amount as we saw in the column name, right? From the temporary view, which is taxi data, close this up, press enter, and it will show you that. So actually I didn't type in show. If you simply type in show, it will show me the actual output of that, and press enter. So now as we can see, the total amount, the sum of the total amount is about $160,000 or rupees, whatever the amount is in. That is irrelevant at the moment, but yeah. So say if we want to actually do something else with this. So say we want to find out a particular fraction, right? We want to find out how much is out of this total amount that we have, the total amount that we've calculated, how much out of this is toll revenue, right? So that is also simple. Simply type in spark.sql, select sum of the toll amount. So here's the tolls amount that we have. So it's TOOLLS underscore amount. So it has to be exactly that. So the total amount of toll divided by the total amount of total amount, right? So we get that, and out of the taxi data. So this will give us the value that we require.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and Dataframe? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
Type in .show after that and press enter. So as we can see, the fraction that we have is about 1.5%. So as we can see, it's about 0.015. So that is the fraction basically about with the ratio of the tolls amount and the total amount basically. And from here on out, it's basically simple SQL. So now you know you only have the only Spark aspect that is coming into it, as we had discussed earlier before. If you're coming from an RDBMS background, the only new thing that you really have to type is this spark.sql. The rest of it is basically the same. And if you want to take out the average amount for each of the trips, you can simply type in select and then type in AVG and given the column name that you want to calculate the average of. So AVG is also a function that is present in SQL by default and given like from taxi data. Close this up and type in .show. So this will give you the average amount. So the average amount for each of the trips is 16 units or $16. And if you want to get a little more complex than that, so say if you want to use the group by clause that is present within SQL, you can use that as well. So if I simply scroll up, we can see that there's a payment type, right? So the payment type and the data description is basically in categories like 1, 2s, and 3s. So all of this is there, right? So if we want to arrange particular results according to the payment type, we can do that as well as we would do in normal SQL. So if we type in spark.sql, say we want to arrange the average, say the average, any column name that we can pick up right now, the fare amount, say if you want to pick up the average fare amount that we're picking up, right? And we want to arrange it by the payment type. So the payment type could happen online, offline, like you pay cash. Sometimes you use online wallets. Sometimes you use cards. So basically all of those things have been mapped to particular numbers like 1s, 2s, and 3s. So that is not relevant to us right now. What we want to do is basically arrange it according to the payment type, right? So simply type in select the payment type, because you need to select the column name that you are grouping the entire query by. So the payment underscore type is the column name that you absolutely want in your result. And then simply type in the average of the fare amount. So the fare underscore amount, it has to be the exact column name that you're using. And then what you could do is simply use from taxi data, but that doesn't end there. You have to also group it by payment type. So at the end of it, simply type group by payment type, close this up, and put a .show at the end of it, and then press enter. So that was actually an issue because we mishandled the column name. Simply type in an underscore after that because that is the actual column name, and then press enter. So as we can see, there are basically 4 payment types that we had, 1, 2, 3, and 4. So all of these could have been mapped to anything. That is not relevant to us right now. But what we know is for each payment type, we have gotten the average fare amount, right? So we can use group by as well. And if you want to go into even more complex territory, we could take a query like which hour of the day on average makes the most amount of revenue, right? So the way we would go about that is simply invoking the SQL context once again. And here we're going to be making a nested SQL statement. So if you're familiar with SQL, you would understand this. We're going to be using aliases in this. So say the first alias we would be calling h24. So h24 would be what our nested SQL query would be. And as R, we also need the average of the total amount for this. So make sure all of these names match. So we're also assigning an alias to this, which is average revenue from, and this would be the nested SQL statement. So this is also a select statement inside of this. Select R, the pickup date time. We'll just look at the column name for once. Just simply scroll up and look at the column name. What is it actually called? The pickup time. So we have the tpep underscore pickup underscore date time. So simply copy this, right? So copy this, and once we scroll down back, erase this and paste it over here. So we have our pickup date time. So this is basically the pickup time of when the trip started, right? So we actually entered our pickup time. Close this up. And refer to this as h24, which we were referring to before over here, right? So our pickup time is h24. The total amount involved in this for each particular hour, basically each particular pickup time, from taxi data. So first thing that we would do is obviously group it by h24. And order all of this. So basically ordering means sorting it, sorting all of the results by the average revenue, which is the alias for the average of the total amount. And if you don't specify the DESC right here, it'll basically order itself in the ascending order, but we want the highest revenue that is generated. So we'll arrange it in descending order. So we get the first result first, right? And then simply close this up and type in dot show and press enter. So as we can see, the R number 22 has the highest average result, average revenue. So the 22 would basically imply the 10 p.m. mark. So in the 24-hour clock, in the 10 p.m. mark, we have the highest revenue, right? So that means 10 p.m. In this particular taxi organization's business, 10 p.m. is the most profitable. So that is basically what the average big data use case statement is. So you'll be asked by your employer to basically calculate these particular insights. So say now that you have that information, you know that you're going to be encouraging your cab drivers to be really active around that time, the 9, 10, 11 p.m. mark, because that is when you get the most revenue and the most profit out of it, right? So out of that. So as we can see, it is simply arranged in that order. 0th means the 12 a.m. mark, the 23rd means the 11 p.m. mark, and the 22 means the 10 p.m. mark. So these 3 hours are the most profitable in that particular order, right? So this is basically what you can do with Spark and the Spark SQL context. And by converting normal unstructured or semi-structured data formats to a data frame and simply running what you would run in an RDBMS system, but for big data.
We will be working on kind of like a real problem, crimes in Chicago, right? So the first thing that I want to talk about here is that this particular problem is taken from a certification exam. So I think an year back in the Cloudera certification exam, they asked this question, okay? Not the exact question, but very similar. So what I thought is like, I'll take a question like that, so you will also understand. In case if you're writing a certification exam, how the questions will be. So people ask. So this is how almost a question will be. And also it is a real data set, a real case study. So that also will be interesting, right? And so imagine that you're writing a exam, certification exam kind of thing, right? So they will give you a problem statement. That is how they do. They give a problem statement, then they will give you a cluster, they will give you the data, everything, and then they will ask you to solve it, right? So that is how it works. Now, the original data for this problem is actually in 4 files. You can see here. There is Chicago crimes 2001 to 4, 5 to 7, 8 to 11, and rest of the data. So the original data is approximately 2 GB. I don't want to use the original data. I want to use this last file called crimes.csv. So basically, these are the crimes reported by the Department of Police in Chicago from 2011 to 2017. And let me show you how the file looks like. Even though the file has many columns and many things, it's a very rich data set. The questions requires us to work only on 2 columns in this particular problem statement, right? But maybe you guys can use this data set to explore further, because like I said, it is a very rich data set. I'll show you what is in the data. So let me open the data set first. So the size of this file is close to 400 MB, and that is why Excel has a trouble reading the file. It will read partly. It cannot read the complete file because the size is a little bit big, right? So it's almost open. Let it open. I'll show you what is in the file. And in certification exams, what happens, in case if you're interested, we will discuss this later regarding certification. But to give you a small idea, what happens is that if you go for a Cloudera certification exam, right, on Spark or anything like that, they will give you like around 2 hours, and they will give you some 8 questions to solve, practical questions. There are no multiple choice questions. It's all hands-on, right? And ideally, if you ask me, I don't want you to write the certification exam. That's my advice, because Cloudera suggests that people should work for at least a couple of years before attempting the exam, right? Exams are tough, to be honest with you. It's not very easy. So if you directly complete the course and write the exam, you will find it very difficult to handle the questions, right? But anyway, you can probably after a year or something, if you get a chance to work, you can definitely write a certification exam. Now this is the file, Crimes in Chicago, and this has many columns, okay? So there is an ID column, there is a case number. We are interested in this column called a date. Okay, the date column. The date column is very interesting because why it is interesting? You have like, the actual date 5/3/2016. So that is like the month, day, and year. And then you have the timestamp 2340, etc. There is an AM, PM as well. I don't know why it is not reading. In the data set, there is an AM, PM as well in the data. I don't know why it's not getting displayed. So the point I'm trying to tell you is that the date column is kind of like completely unstructured, because you have, first of all, backward slash for month and all, then you have column for hour, minute, second and all. So we are interested in the date column. That's one thing. Then there is a block, IUCR code. And the second thing we are interested is this primary crime type. So each line in this file is a crime. So what kind of a crime is it? Battery, public peace violation, theft, motor vehicle theft, robbery. So we are interested in this as well. So these are the two columns which we are interested for our problem. There are many other columns you can explore. I will share a document which explains what is what. Don't worry, right? So, and there are many lines of data. So we have close to 1.5 million lines of data in this, which is good, right? Close to 1.5 million. So this is how the problem statement is going to look like. If you go for an exam, this is how the problem statement is going to look like. So they will ask, choose language of your choice, Python or Scala. So it doesn't matter which language you are using. The data is available under certain location. They will give you the location for the data. And they will say you can check the properties of the file by running a command. And they will say the structure of the data is like this. These are the columns you have in the data. File format is text file, delimiter is comma, and this is the problem statement. Get monthly count of prime crime type sorted by month in ascending order and number of crimes in descending order. I will explain the problem statement later in detail, but that is the problem statement. Then they will say store the result in your HDFS path. They will give a location where you have to store the output of your program. The output file format has to be text. Output columns, very important. They will say that in the output, they want 3 columns. You need a month column that is in YYYYMM format, crime count, crime type, and the output delimiter has to be tab. So this is your entire problem statement. Now I know that for people who are very new to this, it will take at least half an hour to understand the problem, because it's not straightforward, right? If you sit for an exam, it is not straightforward. It's very confusing actually, right? And you will have trouble understanding the problem itself. But I will explain the problem. What I wrote here is not part of the business problem. This is something I wrote to analyze it. Don't worry about this, right? But this is something I wrote myself. This is actually part of the business problem. Okay, fine. So now let us see what they're asking, right? So, okay. So from this data set, what I did is that I just took some sample data to make you understand. First of all, this is the problem statement. Get monthly count of primary crime type sorted by month in ascending and number of crimes per type in descending order. Okay, fine. Output columns, month has to be in YYYYMM format. So our first challenge is we need to get the month in this format, YYYYMM. So I have taken a simple example here. So imagine from the data set, you extracted the data like this. For example, so this is how you're going to extract. So let me just write it so it's easy for you to understand. Control C, Control V. And again, this one, Control X, Control V. So this is 2007. Just hold on for a moment. I'll explain what it is, okay? Don't worry. 2007-03 X, 2007 0, 2. So your first challenge is that even without understanding the business problem, you can understand that they are looking for month in YYYYMM format. This is your first challenge, because the data looks like this. If you read the data is like this. It has, let's say, the month, which is, let's say, 05 slash the day slash, let's say, 2007. Then there is a hour, minute, second. So the data, and then there is an AM, PM. So the column value is like this, right? I don't want this. I want to convert this in YYYYMM format, right? That is your first challenge. And imagine somehow you are able to do it. Okay. So what you will be doing, from each record, from each line of your CSV file, you will extract the month, and you will somehow calculate the number of crimes happened in that month. So it's sort of like a word count. So let us say you're talking about 2007 January. So in 2007 January, so this is 2007 January, right? There can be a crime type called battery, and you collect each battery crime, and then you do sort of like a word count with the month as the key, battery as the value. You figured out that there are like 300 crimes related to battery, imagine, right? And then again in 2007 January, you figured out that there are 200 theft crimes. Okay, fine. Then you land in 2007 July. In July, 100 theft is there, 50 robbery is there. And then you land in March. In March, 300 robbery, 400 theft. Then you land in February. In February, 100 rape, 500 theft. So your first challenge is, from the original data, you have to get only the year and month, okay, and the number of crimes happened. Once you get it, now your problem is, the business problem says, you have to sort the data by month in ascending order. Okay, what do you mean by month in ascending order? See, if you look at here, it's fine, because you are having January. After January, you are getting July. It's okay. But after July, you are getting March. This is not good. After March, you are getting February. No. So I want like January, February, March, July. First challenge. The first challenge is, you have to pick up only the year, month, and also year. So because there is multiple years of data, so after 2007 you should get 2008, and in 2008 Jan should come first, right? Because that is how people want to read the data, right? If somebody is looking at crime data, they want to read it in an order, right? Yearly order, monthly order. So first problem for us is that we have to sort it based on year and month. We are not done. Then they say sorted by month in ascending order and number of crimes per type in descending order. So what does this mean? So if this is your data, I want the output like this. Again, 2007, 01, this, and again here, 2007, 02, this, here, 2007, 03, I think this, 2007, 07, this.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following is the fundamental data structure of Spark? A. RDD, B. Data frame, C. Dataset, D. None of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this data set, the output has to come like this. That too, it has to be tab delimited. I'll tell you how the output will look like, so it's easy for you to understand. So I'm going to use what? Tab as the delimiter. That is my problem. Now I don't want to use tab, but that's what the problem says. Battery 300, theft 200. This is your final output. Meaning, if you look at the final output, what you see is that, first of all, look at the first column only. The first column is sorted in ascending order: January, February, March, July. And within each month, the number of crimes are sorted descending order. Look at January. Battery comes first because 300, then 200. Look at February. Theft come first because 500, then 100. March. Theft come first because 400, then 300. But the original data is not like this. That is what I want to tell you. If you look at the original data for March, this is March. In March, the original data says robbery is coming first, then theft is coming. Line by line if you read. Now I don't want that. I want theft to come first within March because top crimes are theft. Why? Because anybody who want to look at crimes, they want to see like this. If I'm looking at January, I want to see the top number first, right? Battery is number one. I don't want to see the bottom crimes. I want to see the most happened type of crime. So your final output of our today's problem should have 3 columns. They should be tab delimited, and the first column should be month, second should be crime type, third should be number of that type of crime. Month has to be sorted ascending. Within each month, crime type descending. So I'm going to go to my lab. I'm going to connect with the lab. Everything can be done from here. It's very easy, very straightforward. And I have already uploaded the data in Hadoop on my cloud lab. There is a folder called Raghu. Within that folder, we have the data. So the data is already uploaded. And I want to start the Spark shell. So the solution is here. And since we are dealing with kind of like, how do I say, a slightly bigger data set, what I want to do is I want to start the Spark shell, and I have to say master yarn. So normally you do it in the local mode, but the problem with local mode is like you're getting single executor, the amount of memory is less. I don't want to do that. So I'm going to say master yarn. I'm going to ask for 2 executors, and each executor will have 1 GB RAM. So total you get 2 GB RAM and 2 cores. Okay, so let's start it. Let's see whether it gives us resources. First of all, looks like we are going to get resources. And CloudX Lab is running the Spark version 2.1.1. That's fine with me. Any 2. Version is okay with me. They are running 2.1.1. We got the resources. Spark started. See, the version is 2.1.1. And what I'm going to do, the first step is that I'm going to read the data. Anyway, that's required, right? And when you're creating RDDs, do not say A, B, C, D. Give a name for the RDD. So I have given a name called crime data. Crime data is the name of my RDD. So if anybody look at my code, they can understand what I'm doing, right? So this basically contains the crime data. And I'm going to say I'm reading this file called crimes.csv. Now let's see whether it is able to read the file. I can do a crime data doc take 5, and I can say for each println. So take will show you, take is an action. It will show you the first 5 lines. I'm saying for each println, so it will print it line by line. Okay, so we are able to print. So the data, we are able to read the data. There is only one problem. It is also reading the header. This is the header, you know. So the data contains header, and our RDD is also reading the header. I really don't want the header. I will show you how to get rid of the header. Okay. But let's also verify how many lines of data we are having. Crime data dot count. Okay. So when I call an action called count, I can see that we have around 1.4 million lines of data, which is nice, you know. So, okay, so we have data. The first challenge is to remove the header. If I do a crime data dot first, I can see that the first element of my RDD is header, right? I don't want the header. I want to get rid of it. See, there is things like FBI code and all. It's it's proper data. Community area, FBI code, all these things are there. Okay, so how do you get rid of header? It's rather easy. So you can create a variable called a header, first of all. So I'm going to create a Scala variable called a header by reading the first line of the RDD. So this variable called header will have a string value that is nothing but the first line of my data, header data. And now I can use a filter to remove this header from the original RDD. Let me show you. I'm going to create a new RDD that is called crime data without header. So you see the name of the RDD. I'm giving sensible names. I'm not saying A, B, C, D. This will even help me if I want to troubleshoot my program. If I look at this RDD, I know this RDD is the guy without the header because I have named it as crime data without header. So I'm going to say that crime data dot filter. I'm going to filter, and usually you say X, right? So normally when you write an anonymous function, you will say X, then rocket symbol. But here I'm saying criminal record. So each line is what? A criminal record. I can very well use X, but this will be more appealing. So if somebody look at my program, it's easy for them to read. So I'm going to say that take every line. I'm going to filter the data, take every line, and I want all the lines which are not equal to header or not matching with the header. So what Spark will do, it will run a filter transformation. It's going to compare each line with header, and it's going to keep only those lines, which are not matching with the header variable. So basically you will eliminate the header. Now let's look at the RDD, crime data without header. So if I look at this RDD and I will say I want to take 5 dot for each println. Yes. So the new RDD called crime data without header has, this thing gone. The header is gone. We are happy. So we have only the data now. So that is your first step. So Monangi says how it will know that it is header. It doesn't know. I've stored it in a variable, right? Monangi, see, look at here. I'm storing it in a Scala variable. So header is just the name of the variable. It can be Raghu very well. It can be anything. So I'm matching the content of this variable. Header is a variable, Scala variable. Okay. I'm matching. So when I say not equal to header, this header that you read here is this variable. Okay. And this variable contains this data. So basically it will match every line with this data. That is what is happening. Okay, so we got an RDD called crime data without header. So what is our challenge now? The challenge now is I want to extract the date column. I want to extract the date column. So when I say crime data.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Without header dot first. So I'm just typing crime data without header dot first. So you are getting one line of data from the original data. And look at the date field. This is the date field. So it says 3rd May 2016 backward slash. Then you have a space. Then you have the time with colon as delimiter. Then you have a space. Then you have AM PM. So I don't want all of this. I just want only the YY from this, right? So that is our requirement. The problem statement says, give me YY. So what we are going to do, we are first going to read this data and store it in a variable. So I'm going to say crime data without header dot first. That is nothing but the first line of your data. You're going to read it and store it in a variable called rec. What is rec? Rec is nothing but a string. It's not an RDD, it's not anything like that. Rec is nothing but a simple Scala string, but that contains one line of your data. It has one line of your data. Now, usually if you want to develop a logic, what you do is that you take one line of the data and develop the logic. Then you use map transformation to apply to the whole RDD. Do not directly work on the RDD because the RDD is pretty big in this example, right? So what I did, I took one line of data and I'm going to develop a logic on this line of data, right? And what is the logic? So you should also understand what the logic will do, right? So my logic says that from this data, so I will definitely extract what the YYYYMM part, then I will get the crime type. I will also get the crime count. End of the day, I will do sort of like a word count. I will get a crime count also. So if this is your data, 2007, you have in 2007, 01, and then you have, let's say, battery, and let's say 300. Then you have, let's say, theft, and let's say 200. I want to convert this into this format. So how do you know that this is the format you have to convert to? It has to come with experience. You may be wondering, okay, why are you converting this into this format, right? How do you differentiate it is string or RDD? If you look at here, it will show you. For example, the name of my variable is rec. If I type rec, just rec, it will say it's a string. It will simply show you it is a string. But crime data, we have created crime data. If I just say crime data, it will say it's an RDD. So if you simply type the name of the variable, it will show you whether it is string or it is an RDD, right? It's very straightforward, right? And how do you technically know if you call an action? If you call an action on the RDD, the output is not an RDD. That's the rule. Any action you call an RDD, the output will be an integer or a string or anything that you can save it, usually a string, right? Okay, so now if you look at this, my requirement now is, if this is the data you have, let's say in January month, you get battery 300, theft 200, etc., etc., right? If this is what you are getting, I want to convert this into a tuple format, this format. The tuple will basically have your year and month, okay? So if this is your data, what will happen is that I want to convert this data into a tuple format. And in the tuple, I will have the key as your 2007-01, and the values will be sort of like this and this, right? This is what I want to do. This is the whole date column, right? I don't want this whole thing. First of all, I want only this part. So how do you get this part? It's very easy. Let me show you. First of all, I'm going to say that I want to split this string based on comma, because this whole string is having comma as a delimiter. So I'm going to create an array called R, where I will store this whole string divided by comma. Why am I creating an array? So that I can access individual elements. So now I have an array, and in the array, I have all these individual elements. Okay. And the name of the array is what? R. The name can be anything. From the array, look at what I'm doing. From the array, I'm accessing the fourth element. What is the fourth element? First element, second element, third element, fourth element. This is the fourth element. From the array, I'm accessing the fourth element. Again, from this, I'm splitting it using space. So if I have to show you, if I get only this R3, you will get the whole thing, the date, the time, the AM, PM. I don't want this, right? So what I do is that I say further split it using space. So when you split it using space, this will be one, this will be another one, this will be another one. And then you say, give me only the first element, that is the date part. If I hit enter, this variable called D will have only the date part. Okay, so what you do, you say that I want the fourth element in the array. From that element, again, I want to split it using space. From that, I want the first element. So basically, you get only the date in this format, 5/3/2016. But what is your problem? You are not happy because I don't want the date in this format. I want the date in YYYYMM format. What is this format? So this data has to be like 2016-03. But my format is difficult now. It is like 5/3/2016. Right? So I need to convert this data now into 2016-03. How do I do it? It's rather simple. All I need to do is this. So have a look at what I'm trying to do. I'm going to say that I want to split the data using backward slash. So when you split using backward slash, what will happen? You get individual elements. Then I want the third element. So what this will give you? This will give you only 2016, right? And if I say I want d dot split, okay, and then again you say backward slash, and the month will be the 0th guy, this will give you 5. So we are doing a lot of slicing and dicing, I understand, and that is required. So from this entire date column, I split it using forward slash, and I'm asking, give me the last part, that is a year. Again, I split it using forward slash, give me the first part, that is a month. If I do it in a single line and concatenate it, you will have the complete thing. So I will say, give me the last part plus give me the first part, concatenate it, you have 2016-05. So look at this whole piece of thing. All we did is some slicing and dicing. But end of the day, the data we extracted first, only the, what you say, month, day, year part, right? And from this, we extracted the year and month and concatenated so that we have 2016-05. So this is the logic to get YYYYMM from the data. That is your first task, right? I hope all of you understand this because it's not that difficult. It is only basic slicing and dicing. However, we are not done because we are extracting only the date. We also want the crime type, battery, robbery, or whatever it is. So what I want is that I want the data in this format. So what am I trying to do? This M will have your, what you say, month. The variable called M, which we just created, will have your month. I want the data in this format where I need a key value pair. So what I'm doing here is that I'm converting M to integer, then R of 6. What is R? R is our first array where the whole data is. And the 7th element in our data is crime type. So that is like battery, comma 1. Why am I representing my data like this? Because I want to do word count. See, if battery is repeating in 2016 May, I can easily do a word count, right? Otherwise, how do you know how many battery crimes happened in May? If I want to get a total count of battery crimes in May, I need to create a key like this. This key is kind of like a composite key. It has month and crime type, but for each record, I'm calling a 1. So if I do a word count on this, I can see if it is battery, if it is repeating 3 times, it will do a word count. I can see in 2016 May, 3 battery crimes have occurred. This is your half part of the problem. So half part of the problem is doing this, and I can do the whole thing in a single line. That's what I want to show you. So once you develop your logic, ideally you should write the whole thing in a single line. I'll show you R, because not R, I'll show you rec. So we first start with splitting our rec based on comma. Then from there, we get the 4th element, split it using space, extract the first element. This will give you the date part. From there, again, I concatenate to get, let's say 2016 May. Finally, I represent like 2016 May battery, comma 1. This is your first task, or I can say half of the task. 0 refers to first element. So when you are accessing elements in the array, remember we had this Scala collection class, arrays, list, and all. So 0 basically refers first element. Okay. And also it sometimes I guess, in my opinion, you might have to run it by yourself to understand it. Well, I can show you this, but I'll share the piece of code. uh, Probably you might have to sit for some time to run it step by step and understand what it is, right? So right now we have a variable called a t, and if you look at how I created this t, I will get the output in this format. But we are playing with only one line of data. We are not playing with the RDD. So I want to apply this logic to my RDD. So how do I apply my logic to RDD? Very simple. I can call a map transformation. So have a look at what I'm going to do. I'm going to apply the same logic to my RDD. So I'm going to create a new RDD called criminal records with month and type. And I say take crime data without header dot map, and I paste this whole thing. So you see, this is the effect of map transformation. The logic to extract the tuple you have written, but that will extract only from one line. I want to convert each line of my data to this format. So I call the map transformation, and within the map transformation, I type this entire logic, right? So what could have happened is that Spark could have created a new RDD called criminal records with month and type. Let's check out this RDD. And if I say dot take 5 dot for each println, very well. So now look at the data. The whole data is transformed into this. Now do you understand? Look at only battery. How many times battery is repeating in this thing? 3 times, right? I can easily do a word count program here, right? Because this will become my key, and 1 is the value. So if I want to know how many battery crimes happened in 2016 May, or any month for that matter, I do a simple reduce by key, I will get it. I hope you understand the logic behind that. And that is exactly what I'm going to do. I'm gonna create one more RDD. It's gonna be crime count per month per type. So I'm gonna say criminal records with month and type reduced by key. Instead of x comma y, I wrote total comma value, total plus value. So basically it does sort of like word count. So we will get a new RDD. And if I check this guy dot, let's say take 10, I know that this program looks a bit complicated, but you guys asked for me, right? You were crying yesterday, give me production program, give me production program. Now you suffer. Production programs are like this, nobody understand, right? People are like, okay, you are not showing better programs, you're always showing basic programs. If you're not able to understand, I can't help. I can help little bit, but there is no other shortcut, right? You have to sit and read and understand. Production programs are like this only. It's not easy to interpret, it's not easy to understand. See, I can't do both, right? Either I can show you all simple programs, right? But if you say that, okay, I want to see a bit complicated program, the program will have a bit, logic into it, right? And not everybody will be able to catch it for the first time. So what I advise normally is that you take the data set, you take the solution, you break it down, step by step you run, you see what is happening. That is the only way to understand these kind of programs, right? Anyway, we have reached in a situation where now how the data looks like. So I will always tell my participants, before you write the code, you should see how the data looks like. So now the challenge is, I have the data in sort of like a key value pair. Okay. And the key is a combination of what you say, the month and crime type. the value is how many crime happened in that month. For example, in 2012 April, 62 gambling crimes have happened, or in 2004 July, 31 liquor law violations have happened. But now is the real challenge. The real challenge is now I have to sort this data based on month in ascending order. You see, it is not at all sorted. So my first challenge is I want to sort the data based on month in ascending order. At the same time, I want to sort based on number of crimes in descending order. Now, let me tell you one more thing. You may be thinking that it is easy. Okay, you do a sort by key, everything will work. Yeah, I understand. So if I try a sort by key, let me show you what will happen. I'm just going to say sort by key. Okay. Or probably we have to store it as something, right? So this is not part of the program. Sort by key. If I say a dot take 10 println, do you see what has happened? The data is sorted now because you can see that in 2012 January is there. These are all January crimes. Then February will come. But what is the problem now? Tell me. What is the problem now? I applied a sort by key. Did I get my final answer? Is this my final answer? If not, what is the problem here? Because the type of crime I want in December. So in 2012 January, I should first get assault, because not assault, battery, because most number of crime is battery. So this should come first. Then assault should come. Then probably criminal damage should come, right? But the problem with sort by key is that, so the problem with sort by key is that it's sorted based on your key. The key was what? The date, and then your and also you see it is sorting alphabetically. Arson will come first, battery A, B, C, D, G. So your key has two parts. There is a date and crime type. What it is doing in January, it is sorting based on A, B, C, D, right? Now, even if you use sort by, this will not fix, because the problem is here, when you say sort, you can sort either key or value or only one column. And that is my real problem. So if I say sort by key, it will sort based on this, or I can say sort by value based on this. So one way I have to do it is that I can store this as an RDD. Again, I can pick up, the second part and sort it, but that will be very complicated. So I can solve this problem using sort by key again, but that logic is slightly complicated. I will explain that to you. We are going to use sort by key only for this problem. Let me see if I have given it somewhere, the explanation. Yeah, probably I will give you a fresh explanation. So let me pick up some data so I can explain it to you. Probably I will pick up 4 lines of data. So let's say you are taking only these 4 lines of data, okay? And the final output has to be in a different way. You know that, right? Now I'm going to use a logic to sort these guys. So this is my data. This is my original data after sorting, right? And you see it is like 2001, then it comes arson and 39, then it comes assault, then battery, then burglary. So no, I don't want it like this. I have written a logic. I will show you that. So we are trying to explore the final solution, right? So you see, I have written it here a little bit. The data looks like now you have a month column, and then there is a crime type like weapons violation, and then there is a count. This is how the data looks like, right? And what we are going to do is we are going to convert this into a different format so we can, in fact, sort the data. So as an example, if you look at this code, right? So what I'm doing here is that I'm using sort by key for sure. I'm going to sort my data in sort by key. But like I said, if you simply do a sort by key, you will not get the desired output, right? So what I'm going to do here is I'm going to do a map transformation on the data. So let me just copy this whole thing so you'll understand what I'm doing. Yeah. So, sorry, solution, where is it? Right. So the original data looks like this now. So you have a key and a value, right? So in this data, what you need to understand is that, just put it like this. What is the key here? This is the key. And this is the value in our terms, or I would like to call it as a tuple, right? And what am I doing? I'm applying a map transformation. I'm saying that take every record. When I say every record, this whole thing is a record, okay? And I want to convert that into a specific format. Now this looks a bit confusing, but this is the format I want to convert it. So it says rec dot underscore one dot underscore one. So what do you really mean by this? When you say rec dot underscore one, it basically means the key. This is the whole key. Within that, again, you're saying dot underscore one, which basically means this part, right? So this is going to be the key. So let us write it so we can understand. So I'm going to take the first row of data. Okay. I'm going to take the first row of data, and rec dot underscore one is nothing but my key. Within that, again, dot underscore one is this part. I'm going to take this part, Control C, Control V. So this is this part, comma, negative value of rec dot underscore two. What is rec dot underscore two? That is nothing but this 39. Negative value of 39. Why? I will tell you. So I will convert this into negative, let's say 39. Okay. Then what I want to do, comma, so this comma, rec dot underscore one dot underscore one again comes here. So which is nothing but your 2012-01. And then I put a tab. So you see there is a tab here. And then what happens? You have rec dot underscore two. That is nothing but 39. This is 39. Again, I put a tab. Again, I say rec dot underscore one dot underscore two. That's nothing but arson in the first case. So my point is, this line is getting converted into this format. So what you need to understand about this format is that this is one part. It's like a key value pair. Then there is a tab. Then there is the crime number. Then there is a tab, and then there is arson. Right. So let me keep it separate so it's easy for us to read it. And also I'll remove these commas and make it a more nicer to read it. Right. So this is one line. Similarly, all four lines will get converted. Right. So I think it is very similar. Right. So I can just do a copy paste. Control C, V, V, V. So this is going to be 2012. All are 01. Right. And the second one, the number is going to be what? 1294. Okay. And this is also going to be 1294. And the type is what? Assault. Okay. And the third one is going to be what? Negative 4307. Okay. And also going to be 4307. Okay. And this is what? Not arson. This is what? Battery. The last one is 1757. Okay, and here it is going to be 1757. And this is what kind of a crime? Burglary. So your original data, which was in this format, gets converted into this format. This is first thing you need to understand. Did you understand how did I convert it? It's very simple because you are just accessing the elements. I'm just saying that take every line of data and I need a key value pair like this, where the key is going to be the year, the value is going to be the negative count. I'll tell you why it is negative, comma, again I will put the year. Okay, so this whole thing is what you see here, this first part.
Just a quick info, guys. Test your knowledge of Spark by answering this question. Which of the following are the common feature of RDD and Dataframe? A. Immutability. B. In memory. C. Resilient. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answers. Now, let's continue with the session.
Then I put a tab and then I say, give me the second part of the data, that is the crime number 39. Then I'll say put a tab, again I need a tab, and give me the crime type, that is arson. So this data gets converted into this data. Now let me tell you why I did this negative number. There is a logic behind it. Okay, what is the logic? If you look at my solution, where is the solution? Yes. Can you tell me what will happen if I do a sort by key now on the above data, on this data set, on this data set? Okay, by the way, in this data set, what is the key and what is the value? So this is going to be the key and this is going to be, these are just extra elements. These are not key or value or anything. This is what you need to concentrate. And this part is the key. This part is the value. If I do a sort by key, what is going to happen is that definitely it will start like January, February, March. The year will be sorted in ascending order. Within each year, what do you think will happen? These are negative numbers. So when you sort negative numbers in ascending order, is negative 39 bigger or 1294 bigger? What do you think? Which one is bigger? Negative 39 or negative 1294? Which one is bigger? 39 is bigger. 39 is bigger, right? When you talk about negative numbers, 39 is bigger and this is smaller and you are sorting in ascending order. So what will happen naturally, this line will come first. If you do a sort by key, this line will come first. Why this line is coming first? Because the smallest number here is negative 4307. Negative 4307. This is the key. You are touching only the key. Already you sorted based on January. Within January, you have 4 values and the lowest value is minus 4307. What will be the next candidate? Next candidate will be this guy because that is the next smallest one. What will be the next candidate? It will be this. What will be the next candidate? It will be this. Do you see what has happened now? What has really happened is that using the negative technique, you did ascending, descending sorting in the same piece of code, right? And now what I can do in the final output, I don't need the key. If you understood this much, what I can do is in the final output, I will say, I don't want the key. Yeah, I don't want the key. I was using the key for sorting. So if I copy paste this in the final output, okay, the key will be removed because you can omit to remove the key. And does this look like your expected output? Yes, it is. The year and month is sorted in ascending within each descending order for your crime type. I know it's a hard to understand, but this is what we are doing in the piece of code, right? So I used a negative number only for sorting so that I can retain the corresponding values. So when you sort, the remaining data also gets sorted, right? So when I say for negative 437, after a tab, I have a positive 4307, which is getting kept here. So naturally, the other part is getting sorted as well, right? So what we did, I'll just repeat once more, but I don't think even if I repeat, if you didn't catch it, you may understand. The only way to understand this is to run your code, right? I'll give you time to, I'll give you the answer. You can run the code and all, right? So I'll explain this once more. This is your original data. The original data gets converted in this format. And I think that part you have already understood, right? So now your data looks like this, right? And the data has a key, which is a combination of month and negative value of crime count, the value, again that is a month, then a tab, crime count, and crime type. So that is how the data looks like now. And what I do, I run a sort by key on this data. So when I run a sort by key, since the key is a composite key, the key contains two parts, it's first gonna sort based on the month and year. So 2012, Jan, Feb, March, or 13, like that it'll come. Within 2012, it's gonna identify that there are 4 values. And sort by key, by definition, since it does descending, it's gonna choose the smallest value first. So naturally, negative 4307 is going to come first. Automatically, since your data also contain the positive value, this guy will automatically become the first element here. And then 1715, 1294, 39. So your sort by key output is going to look like this. And then I can say, I want to avoid the key because the use of the key was only for sorting. I want the remaining data, you get the output. Now let's do this in the code as well so you can understand. So where are we? Yeah, so we are here. Crime count per month per type. So the data is like this. Now the whole thing I wrote like a single line. There is no other way. But if I do this, you will understand. What I'm doing here is that I take the data. I will run a map transformation to extract the data in the format we have given. Then I do a sort by key. And after that, I will say I want only the second element. So I'm basically removing the key part from here. So now if you take the final RDD and do a take 10 and say for each println, see, now this is the expected final output. 2012 January, the most cases are theft, then battery, then narcotics. So you can see that the month is ascending and crime type is descending. Also the delimiter is tab. So this is the problem with certification questions. They want everything to be in the proper order. Now, if you think about the problem statement, you see how do you productionize a Spark program? So let me just delete some of these things. These might be required. So the next topic is how to productionize programs. Or in a very simple way, if you are a Spark developer, how do you write Spark programs? Will you actually take the Spark shell to develop this, right? For example, if you are a Spark developer working in a company, how do you write a Spark program? And how do you test it? Then how do you execute it? So the first thing that you need to understand is that if you are working as a Spark developer, one thing you can do is definitely you can look at the Spark shell. But that again is kind of like, I don't know. See, you have to type line by line and then see and So usually people prefer an IDE. So if you are a developer, and the first thing is that so let me write the things that you need to do. You have to download, let's say, IntelliJ. Now you can do this on Eclipse as well, but when it comes to Scala, IntelliJ is mostly preferred for Spark programs. So first step you need to do is that you have to download this IDE called IntelliJ. How do you download it? Very simple. You go to Google and just search for IntelliJ. You will land on the official website of IntelliJ, right? IntelliJ has a paid version and a free version. So if you click on the download link, it will show you the ultimate version and the community version. Ultimate version is the paid one. Don't download it. Community version is the free one. Just click on download. It will download, install it, and you will be having IntelliJ. Now I have already installed IntelliJ and I can show you that just to do this. Now, surprisingly, many of you will know this, but I see in every class, there will be some participants who are not aware of this. In order to run a Spark program, you don't have to install Spark. I don't know how many of you get this idea. So I am going to run a Spark program on my Windows laptop. Okay, I will run it and show you practically. I will run a Spark program end to end on my Windows laptop. And I will not install Spark. I don't need Spark at all. Well, Spark is required, but My point is you don't have to download and install Spark. Why? Because you need to use something called build tools. Now see, if you're writing a Spark program, then you will be definitely using Spark libraries, right? So Spark has lot of libraries. So if you're looking at this Spark context, SC, they are all part of your Spark core library, right? So usually what we do is that we use something called a build tool. There is something called a build tool. So step number one is you download IntelliJ. Once you download, you start it. It will look something very similar to this. Step number two is download the build tool called SBT. There are many build tools. If you talk about them, there is something called Maven, there is Ant, there is Gradle, there is SBT. There are many build tools. What is the purpose of a build tool? A build tool can basically take a requirement from you. So I'm going to use something called SBT. I will download and install SBT on my Windows laptop. Okay. Once I download and install SBT on my Windows laptop, I can go to SBT and tell SBT that, boss, I have a Spark program to compile. Okay, I need Spark libraries. This SBT will go to internet and download all the required libraries to compile my program. And it can do that for any open source project. So build tools are very popular. So for Spark programs, the most popular build tool is SBT or Maven, whatever you call it, right? So how do you install SBT? It's again very easy. You just go to Google, you say download SBT, and the first link is SBT download. It's pretty straightforward. You can see a .msi file for Windows. Click on it. It will download it. You will get a file. Next, SBT will be installed. I will show you how to build the program and all. Don't worry. Okay. But you need to download and install it. SBT actually stands for a Scala build tool. And it is not only for Spark. Any Scala project you can build using SBT. Spark is one of the frameworks which is written using Scala, right? There are many other frameworks. In all of them, SBT is a very popular build tool. So once you install SBT, SBT is a command line tool. There is no graphical user interface. There is no GUI or anything. So what you can do, you can open the command line, Windows command line, CMD, and just to check whether SBT is installed properly, you can type a command called SBT about. So there is a command called SBT about. If you run this command, let me run this. It will show you so many things. Don't worry. So it will show you so many things. Finally, it will show like this. This is SBT 0.13.16. So it is just showing you the version of SBT. I have a slightly older version. If you guys are downloading now, you may get a latest version. That's perfectly fine. But this is how you test whether SBT is properly installed. Just run the command SBT about. It should simply show you the version. That means everything is working fine. You're happy, right? Okay, so these are the prerequisites. You need to have IntelliJ, you need to have SBT. For Python, I don't know what is a build tool. Honestly, I don't know. I have never built a Python program, so I don't know. You need to check. There might be a build tool, or probably they are using some third-party tools. I never got an opportunity to build a Python program, right? Full name of SBT is Scala build tool. Scala build tool. Now the problem is you need some program, right? So once you download IntelliJ and then download and install SBT, you are ready to productionize your program. So naturally your question will be that how do I productionize my Spark program? So what do we do normally is that we will write a Spark program and test it locally. Spark can very well read from your Windows laptop or Linux or Mac or anything. So usually what I do is that if I have to develop a program, I'll take a sample data, copy to my C drive or D drive. I'll write everything inside IntelliJ. I'll read the data, write all the transformations, run it. I can even see the output on my IntelliJ. Right? Everything can be displayed in IntelliJ. So if everything works for me, I say, okay, everything is nice. What I will do, I'll just change the location of the data, compile it, and then run it in the Spark cluster. So end of the day, if you write a program, you have to compile and produce a jar file, jar file. In MapReduce, so MapReduce programs, I think you created a jar file, am I correct? You compiled it and created a jar file, right? And then that jar file you are running, correct? Yeah, very similar to that. Here also, you need to compile and create a jar file. Let me also show you the data. So I have written a simple program. If you look at the code, where is the data? I think it is in C data. So retail DB, order items. Yeah. So you are reading this file. See, there is a file called a part 00000. So this is nothing. This is basically some transaction data that we have. And let me also open the code and see what we are reading. So 1 and 4. So if you look at this data, this is the order ID. The second column is the order ID. Can you see? 1, 2. And the third and after that, the fourth and the fifth column is the amount. 299.98 is the amount. So if I look at the first line of data, the order is 1. Okay, that is the second value. And the amount is 299. If you look at the remaining 3 lines, what is order ID? 2. So under same order ID, there are 3 transactions. Okay, because in this line, the order ID is 2, amount is 199. Here, order ID is 2, amount is 50. Here, order ID is 2, amount is 99. So basically, you want to calculate total revenue per order ID. It's again like a word count program. So you will be taking this 2 as a key and this thing as a value, and then you do a reduce by key, you get the output. So I'm not really interested in the program. Rather than the program, I want to show you how to productionize it, right? So I have written a program. Now, when you write a Spark program, what are the things that you need to take care? First of all, who can tell me what is Spark context? Who can tell me? What is Spark context? Okay, Spark context is not the driver program. Okay, it's part of the driver program probably. It's part of the driver program. Let me ask you this question. In the Spark session, you have Spark context. Why do you need it? So the new way is Spark session, right? Even in Spark session, you get Spark context object. Why do you need it? So the answer is Spark context is the object which will communicate with your cluster manager like yarn, right? Spark context, remember the driver will communicate with cluster manager using Spark context object. So Spark context is not the driver, it's part of the driver. But when the driver want to talk to executors, driver want to talk to yarn, it uses this Spark context object. And normally what happens when you start the Spark shell, the Spark context will be available as SC. That is why you say sc.text file and all. So when you want to read something, you will say sc.text file, right? So if you are using a shell, the Spark shell, the Spark context object will be automatically created for you. But when you're developing a program, you need to create your own Spark context object. That is a rule. So in a shell, it will automatically appear. In a program, you need to create it. It's a class. You can basically call and instantiate. Basically, it is a class. You just create an object out of it. That is all you need to do. Also, you need to create something called Spark configuration object. What is this Spark configuration object? So I told you that if you're writing a Spark program, you can put all your configurations in the program. For example, whether my program should run in local mode or yarn mode. What is the name of my program? In what port number it should run? How many executors it need? How many processor cores it need? All these settings, okay, settings and configuration, you can add in the configuration object. And using the configuration object, you will initialize your Spark context object. So what the steps are like this. First, you create a Spark configuration object, and using the Spark configuration object, you initialize the Spark context object. This is what is going to happen. So when you write the program, I'll show you how this can be done. So you can import the Spark libraries, and all of this are available as libraries and classes. You just need to say new for creating an object out of a class. So first you will create a Spark configuration object, add some properties to that, and using the Spark configuration object, you will initialize your Spark context object. Once you have the Spark context object, remaining code is same as you know. If you observe a MapReduce program, it is also very similar. I don't know how many of you have seen a MapReduce program. In the MapReduce program, in the driver part of the code, you will create a conf variable, configuration, right? And under that conf variable, you will call the mapper class, reducer class, everything. So the idea is same, but we have to manually create these things inside our Spark program. That is the prerequisite. Once you create your Spark context object inside the program, then you can read the data, write it. Now, like Monangi was rightly pointing out, there is another thing called Spark session. Spark session is the new way of accessing, it is a new entry point to Spark's functionality. There is something called Spark session object. We will talk about that more in the Spark SQL class. But in the modern programs or the latest programs, when you look at the program, they will create something called Spark session and then initialize Spark context from the Spark session. Either way, you can do it. It's up to you. Without Spark context object, nothing will work basically in Spark, because that is the object for communication, right? So driver and executors, driver and cluster manager, they talk using this object.
Now let us look at the career opportunities in Spark. So isn't Spark doing a great job? Also, it is a fact that Apache Spark developers are among the highest paid programmers in the Hadoop framework as compared to 10 other Hadoop development tools. As per a recent survey by O'Reilly Media, it was evident that having Apache Spark skills under your belt can give you a hike in salary, and also mastering Scala programming can give you a further jump in your annual salary. This is the best time to start your career in Spark.
Just a quick info, guys. Intellipaat provides Apache Spark and Scala certification training mentored by industry experts. The course link is given in the description below.